This is in commemoration of the EMARC students who started in 2021 and are about to submit their dissertation in 2 days. Today we will have 5 students presenting, covering various climates, Turkey, UK, and India, but from different cities. And we have some reviewers, so in addition to me and my colleagues, Simos Llanas and Joana Gonçalves, we have also Rafael Alonso, Florencia Colli online, and Olivier Dabron. The 3 of them are ex-SED graduates. They finished in 2016 and 17, and they have remained here in the UK. They formed a company, a consultancy company called Atmos Lab, and you are welcome to join us later. They will be our keynote speaker. So if you can't stay for the whole session, join us at 6:30 to have them to hear or listen to their presentation. Thank you very much. We will start with Elif Neva.
Okay, hello everyone. Thank you for being here today. I'm Elif Neva Beşkonaklı, and I will be presenting my dissertation topic today. My dissertation title is Prefabricated Modular Housing Design in Istanbul, Turkey. And this presentation consists of 7 parts. First of all, I will be introducing my topic with a brief climate analysis, and I will be moving on to the design development, and the analysis of the decisions. So my dissertation topic is adaptive and compact housing design in dense city centers with prefabricated construction systems. And overall, the main focuses and aims of this dissertation are achieving adaptive housing design, benefiting from passive design strategies, reusing features from vernacular architecture with improvements, and overall achieving good building performance. Moving on to the climate, the project locates in Istanbul, Turkey. It is one of the densest cities in Turkey, close to 16 million population. Istanbul has a transitional climate between a temperate Mediterranean climate and a temperate oceanic climate, with warm to hot, moderately dry summers and cool to cold, wet winters. Looking at the annual hourly climate, the cold period is from December to February, with limited solar radiation that barely reaches 400 watts per square meter. The temperature always ranges below comfort band, and in January and February it sometimes goes below 0. During summer, temperature generally ranges in comfort band with some overheating days in July and August. So overall, the primary concern would be the cold period. The monthly average air temperature shows the cold period has a 7.9 average, with the coldest month being February with an average of 7.2 degrees. And the warm period has an average of 24.2 degrees, with the August being the warmest month with 25.4 degrees Celsius. And comparing it with the 2080 A2 future climate scenario, the monthly averages will be increasing 1.2 to 2.8 degrees. Throughout the year, wind speed and direction are consistent. The dominant wind direction is northeast all year. The frequent wind velocity is about 5.3 meters per second with 25% frequency. So this section will be summarizing the evolution from early settlements to today's housing condition, and some of the problematic aspects and what is being lost in this process. So So before immigrating to Anatolia in the 11th century, Turks lived mostly a nomadic lifestyle in the Middle Asia, which means that temporality was the main principle in the early settlements, and the spatial layout of the settlements had high mobility and adaptability to different uses, conditions, and occupants. So in the tents, they were laid out separately, belonging to different units of the family and creating a central space in the between. And this convert to the vernacular timber houses. It's pretty much developed from inner space to outer space, just like the nomadic tent. And some of the important features, first of all, is, again, there's a common space where the rooms open up. This is used as a multi-purpose transitional space, can also be interpreted as a square that connects all rooms. And wood is generally preferred for lightness, easy manufacture, and availability in the geography. And another important feature is the projecting bay windows. While the ground is sitting on the stone, the upper floors were adjusted with the bay windows for privacy, sun, and ventilation. And the external shutters were operated for hot summer days and cold winters. However, in contemporary concrete blocks, quite a lot of things have been lost, and the housing scarcity encourages developers to embrace this type of typology. And some of the problematic aspects are the deep plans, strong division of spaces, isolated living room and kitchen, lack of consideration of orientation or occupant comfort, and lack of quality in building materials and interior finishes, because the first aim is to build really fast. So the design concept basically covers what is problematic in current state and what can be improved. And living area mainly should come back to the center, and less isolated rooms should be formed. Vernacular elements should be integrated. There needs to be more attention given to the orientation and what's going on around with the obstructions, and more compact design that also allows easy assembly and construction. So the ideal module brings together all the main design concept and environmental concept ideas. It is very compact and only provides essential facilities. With the addition of the base window space, it's 35 square meters. The living room and the kitchen comes back to the center, and other functions are surrounding from the center. The separation between the different function of the spaces is flexible, and for double aspect units, openings can be provided in the bathrooms for daylight. The addition of the bay window is functionally quite beneficial for a very compact layout, but at the same time it can be used as multi-purpose, like dining area, lounge area, or office. So the unit is constructed 1.2 by 2.4 CLT panels. The different configurations of panels can provide different layouts. The main benefits of prefabricated construction are efficient, fast construction, and high quality building envelope. And according to the transportation regulations, the module would consist of two parts, one including the and the other living room, bedroom, and kitchen. So how these modules can come together. The project site is located in between the business center and residential area called Levent in Istanbul. The surrounding buildings are in close proximity, about 4 meters, and the street is quite narrow. The residential buildings are 2 to 6 stories high, having small local shops around the ground floor. The project site is 19 degrees rotated to the north-south axis. There are roads to the north, main roads to the north and east. The south and west sun would be blocked by the surrounding residential buildings and the predominant wind in the northeast direction. The road on the east side is busier than the road on the south. Therefore, the apartment entrance is placed on the north and retail spaces are placed on the east side. Considering the compactness of the module, there's also a storage space given to the residents on the ground floor. Moving on to the massing study reflects the site analysis. First, the raw massing site is offsetted from the streets to create adequate spaces because these facades also have windows. And the retail lobby and storage space is placed on the ground floor and modules are being stacked on top. The common spaces are strategically placed in between the modules on the south and east facade with the core and circulation pad supporting these spaces. As you can see, the modules are oriented east and north where the main roads locate due to the limitations on the west and south facade and the close proximity of the buildings. So it will be built with stud wall construction where the bathroom units and room units will be delivered and it will be stacked on together and the bay windows then would be in addition. The roof, facade and the circulation would be built on site. Again, the units are mainly oriented to main roads where they can also be benefited from solar gains. Coupling the units in the north is important and the common spaces were integrated conceptually as the transitional central space. Also the compactness of the units and occupants being students or young professionals, it's important to have these areas. Looking at the solar radiation, it's during summer on east facade, where most of the units are oriented, gains radiation around 200 kilowatt hours on the top parts, and it reduces to 100 moving below. On the north facade, there's very limited potential, around 70 kilowatt hours per square meters. And also during winter, all facades receive very limited radiation except the top floors of the south facade. As there are very limited solar radiation during winter, in order to achieve thermal comfort in the modules, it is important to have an efficient envelope design and use of adaptive opportunities. So analytical studies basically focuses on two modules, one looking to the east and one looking to the north. There are four main cases that has been illustrated here. The base case uses conventional construction, concrete, and without any bay windows. The first case is addition of the bay windows and changing the construction to prefabricated CLT panels. The second case would be bay windows and interior shutters, and the third one would be addition of the glazing on top of the bay window roof. The thermal simulation results show that during winter, the indoor operative temperature of the east module has potential to increase about 5 degrees from the base case on sunnier days. The indoor temperature remains stable, slightly below the comfort band, between 18 to 21 degrees. During summer, compared to the base case, the glazed roof case increases the temperature about 4 degrees during the day, while keeping the same temperature at the nighttime. During spring, the indoor temperature of the east module increases about 3 to 6 degrees from the base case and ranges generally in the comfort band in free running between 20 to 26 degrees. During summer days, we can see the importance of the radiation as the extra glazing of the bay window sufficiently heats up the space. And in order to avoid potential overheating, roof shading should be operated accordingly. In autumn, the temperature increased about 5 degrees and stably ranges in comfort band. The most affected season can be observed as spring and autumn. In the East unit, the thermal comfort in free running mode shows only the addition of the bay window increases the comfort hours 7%. In East units, comfort hours increase total 23% with the addition of the bay window, interior shutters, and the roof glazing. And of course, some overheating occurs in the spring and summer. Looking at the North unit, during winter, the indoor operative temperature of the North module increases about 3 degrees again from the base case, and mainly on sunnier days. And the indoor temperature remains stable below the comfort band between 15 to 21 Celsius. During summer, compared to the base case, the glazed roof increased the temperature by 4 degrees. Again, during the spring and autumn, we see the most increase in operative temperature. The thermal comfort in free running mode for North unit is increased 6% by only the addition of the bay window and the addition of interior shutters and the glazed roof. In total, increases the comfort hours 24%. Overall, the primary concern in the winter period, the operative temperature of both East and North units ranges below the comfort band, ranges slightly below the comfort band. It is seen that the addition of bay windows is efficient for both orientation, both north and south. So the heating demand, looking at the cold period, from base case to the last tried case, for north it decreased from 25 to 13, and for east it decreases from 24 kilowatt hours to 11. For daylight studies are run for 2 different targets for different spaces, 300 for living spaces and 100 lux for circulation and bathroom. Due to the open and narrow floor plan, the addition of the bay window, living spaces reach 300 lux target more than 50% of the time, and even the far back of the module receives 300 lux at least 30% of the time. The circulation path receives daylight from common areas that opens to balconies. The units that have double aspect reaches the target around 50% of the time. However, it is being lost for units that don't have the 2 double aspect. For conclusions, the compact unit provides essential facilities and spaces that is for 1 or 2 people to occupy the unit. The addition of the bay window, which is a traditional feature, is a multi-use space that can provide functional benefits and environmental benefits. Analytical studies shows that there's also thermal and daylight benefits. Overall, for both East and North orientations, additional of the bay window brings benefits by providing daylight and becoming a solar protector, solar collector, by opening up to the different orientations that the units would normally not opening up. And having high glazing ratio, the bay window makes the space more sensitive, so therefore shutters and additional insulation during cold nights is important. And further studies can be conducted with the operation of the shading devices and the right now conceptual partition between the bay window and the actual module. Thank you.
Thank you, Neva. Maybe we can start with Florencia from Argentina. Do you want to start?
Hello. Okay, so thank you, Elise. I think you have an extremely clever module design. I think that I was trying to imagine how one or two people can occupy it, and there is something that you didn't mention, but that I thought was great. I actually found that the unit itself is very functional, and it's clearly intended for one or two people, and that bay window adds a variation that I find very interesting. In the end, I think that your bay window is the individual space to enjoy privately. It's the space that is bright. It's a space that will have the sun. In the end, you don't need the entire module to be perfect, because you have the common spaces that you mentioned, and that bay window adds a variation. The concept of variation that bay window adds, I think it's very nice from the point of view of the use. So I think that your module design was super clever. I would have personally loved to see more about the common spaces, because I think that quite a lot of the individual space plays with the common space. But I think that in general it was very nice, and how you managed to combine the practicality of the prefabricated module with one space that adds life and variation to the unit itself. I don't know if I talk about, but I cannot listen much.
Hello.
There we go. Thank you, Ben. Thank you, Florencia. So maybe Rafa?
Yeah. Thank you, Elif, for the presentation. So it was very clear to follow your outline and to understand. You took us very well through the climate, and what was the problem, and then the side of the module, then how they come together. I think, I know that this is time constrained, but I would have liked to see a little bit more of the context on Istanbul itself, like why there is a need for this housing or not, and how big it is, this need. I'm sure it's there, but just for someone coming as a newcomer, it helps to frame the problem that you're solving. I saw that you did a lot of detailed studies on the unit, which are super thorough, and I quite like that. I think it was great, especially the bay window that Florencia was mentioning. It was very smart on how you combine something that is very rational almost with something that is bioclimatic, that adds that life to the project. I guess that one cannot do everything, and the problem is when you design a modular system, then you try to implement on a site, it gets on this balance on how much do you standardize your unit, or how much does it vary on a site. And I guess if you were to pursue this project further, that it would be interesting to see how your module can adapt to different conditions on your massing, whether the modules on the top are the same as the modules of the bottom, or those looking to the south, that you don't have anyone in this case, are different from those looking to the north, like that kind of exploration going forward, no? But overall, I think it was it's a very good project. It was very easy to understand your thought process, and yeah, thank you.
Thank you, Rob. Maybe Olivier?
Sure. Well, thanks for your presentation. Very, very clear, and as Rafa said and Flor, it was very easy to follow. I think you may have done the research, and probably you know, but I would have liked to understand more of what you found on the benefits of doing a prefabricated. Basically, what's the advantage of it? Probably there are some in terms of carbon, transportation, efficiency in production, and cost, and all that. So, in the end, you're studying and going in depth in that, and maybe for someone who doesn't know, it would be a good exercise for you maybe to explain all the benefits of that, because then it strengthened the case. And maybe you explained it. I wasn't sure if I missed the point, but I suppose that the bay windows, every floor is somehow staggered, so that I was wondering whether the solution of having the glazed roof of the bay window wouldn't be overshadowed by the one on top of it. So I was wondering if you arrayed the units, yeah.
Basically, the shifting of the, yeah. Well, because the thermal simulations also show there's good benefits of the solar glazing, the bay window gets shifted in the floor plan. However, sometimes that means it is attached to not the living space, but the bedroom space. But ideally, we would like it to be attached to the living space. But that's where the shutters come into play. I was thinking as this adaptive, giving the occupant the adaptive opportunity. I'm sure there's other solutions, but basically when there's over-illumination of the addition of the bay window to the bedroom space, shutters would be closed, and nighttime there's shutters closed anyway, so.
Yes, thank you for your very clear presentation, Neva. It was very easy to follow, very well presented. I just have a couple of comments. On a very positive note, I mean, overall, I like very much the way the project embraced the challenge of contemporary density in housing design. So I think it's really good to emphasize that, you know, the minimum square meters of usable space you're dealing with, how do you manage to fit all of that, is a big challenge, and we need more and more thinking on this. But then at the same time, you manage to keep some absolutely key environmental features, architectural features, the bay window, but also the so-called sofa, isn't it, that common area on the plan, that becomes a communal space. And I think that's a lovely gesture, because it's a change in lifestyle too. What it was understood as a family space is now a community space, and maybe the new family, you know, is the neighbor, the neighboring relationships. So I think it's very suitable for today's living. It's still a relief. So there's a lot to talk about that space that came out of the private, residential, domestic space and become something more shared. And you have it. So I'm just emphasizing that, because I think it's a super important architecture and new environmental feature. In a way, you're reinventing that space, in other words, socially, with great environmental benefits that, like Flo was saying, if you could highlight that, I think it would be a plus. And then the bay window, you emphasized a lot the percentage, how many percentage of comfort hours is being increased because of it. And completely right, but I think before that, what is more important about it is the conditions that it creates, that allows people to be under the sun, super exposed to wind if you want, because they're very close to the window if it's a warm day. And I would strongly advise you to bring that forward, first and foremost, before the comfort percentage annual studies. Yeah, and in a way it's a reinterpretation of the vernacular, very efficient environmentally. If it's 11 kilowatt hour per square meter on the north, maybe would you dare to say you can be 0 if it's on the south, if you get a lot of sun in the winter? That could be good to see. But I stop here, yeah, because of time.
Okay, then I follow from here. Thank you very much, Neva. It was a very good presentation, and I really like the way how you adapted the traditional sofa and also the balcony or the bay window into the modern lifestyle. I would add only that, and also in sequence of what Joanna just said, which is nice that you adapted this sofa to a more communal space. However, we didn't grab very much what sort of occupants will be there. You know, are these families, are these young couples, or does it cover all type of generations? So maybe having a little bit more of this information would have helped. And the only other comment I have is in regards to the bay windows. You have focused a lot on the shutters, which you demonstrated how useful it was in terms of avoiding heat losses during the winter, and I know your focus was the winter period. However, I noticed from your visualizations that there were no other sort of solar control, because the shutters you have, they are opaque, so they would block completely the light. And you have some of these balconies facing east and west. So sometimes daylighting can be, or solar radiation can be a bit annoying in terms of daylighting quality. So I think that's the only piece of information which I think you should also demonstrate. Thank you very much.
So well done, Neba. I think the project has developed really well. As you know, and we have already discussed, that there are more things that can be explored, and I would strongly encourage you that you stay with this project after its completion for the MArC and continue to develop, because there is a lot of learning and potential in this. One thing you haven't covered in any detail is the future. You had shown in the very beginning that there was some understanding of how the temperatures might rise, and it sounded significant, up to 2 degrees, although I'm not clear for what period. Well, if it is significant, then it's worthwhile looking at, and we'll leave that aside. How are we going to look at it, and what can we do? Well, then we can come to the bay window. The bay window, as you know, has not been fully examined, investigated. All sorts of aspects are there, but where it finds its, let's say, technical maximum is not yet clear. I have a suspicion that its technical optimum is one which perhaps will become expensive, because it will involve both something like what you've called shutters against the glazing of the bay window, but also a strongly insulated partition between the room and the bay window. And the reasoning for this, which can be confirmed by simulation, although I'm almost certain this is the case, is because through this project we understand that the thing called bay window is an intensifier, I would call it, intensifier in quotation marks, of environmental forces. You put it there, it increases the heat loss. It increases the solar gain, by definition, because it has more exposed glazing. And then you put something that reduces it, it reduces that. So it is an element, a component that intensifies the processes. And, well, what you want is an intensification or normalization that suits the occupancy, which on the one hand will increase the comfort hours, but the comfort hours are just a numerical incentive. Seeing that is happening, in other words, that from 60% you can go to, say, 80%, then implies that other things that we associate with the comfort hours in terms of thermal may also become available more intensively. Or if they were going to introduce something that has a negative influence, then that there is a reduction. Another thing that is worth pursuing, and I think it was mentioned implicitly, is what might be the effect of constructions and bay window inclusions like you're proposing to the whole area. You know, you have showed that with relatively simple measures, you're reducing the heating load by half, from 24 to 11, something like that, which is a very substantial reduction, both numerical and percentage. Of course, when we go to small numbers, then the percentage and numerical reductions are really very small. But here, from 24 kilowatt hours per square meter over the year to 11 is pretty substantial, and in fact meets almost any standard of the ones put forward by Passive House or national. So it would be good to see if more construction in the area was developed and was applied in this way, what kind of effect would it have? Yeah, that's all I have at the moment. Well done.
Okay, thank you. I don't know if there is any question from the audience. Yes.
Hi, my name is Layla. First of all, congratulations, it's really well presented and really concise. But I was just curious about one thing. I understand that you did the bay windows in a staggered way in order for each module to have equal opportunity. But I'm curious is that, I don't know if you already mentioned it or not, but the flooring, the floor that you studied, is there a specific floor in the building that you were studying in general? So is it the last floor, middle floor, which one exactly?
That's actually a very good question that I forgot to mention. Both thermal and daylight studies were done in the 5th floor here, and it's the middle floor. Do you have a question about what?
Yeah, I can just raise my voice as well. Is that fine if I raise my voice? Yes. Okay, fine. So what I'm curious about specifically is that I understand again that they're staggered and it's okay. Thank you. I understand that it's staggered to allow equal opportunity in terms of temperature, daylighting, etc. But what I'm wondering is that if I understand that you studied the middle floor, I wonder if, for example, the last floor tended to overheat more than others because of the other floors being overshadowed in general. So I wondered if there was any approach to that, because I can understand that, for example, if you did put glazing on the roof on the last floor, maybe there is a higher impact to these modules. So I was wondering if did you approach that in any way, or did you find that all or most apartments had similar results that didn't have that much of a difference, so it's more homogeneous?
Normally, it should change the top floor and the bottom floor for daylight and for thermal too. Even on the same floor, north, there's a south unit also. There's a corner unit, which there's another corner unit. So all of them would have maybe close, but not the same results. One representative east and one representative north is selected just to keep things a little bit more focused, rather than adding multiple parameters and getting confused. Mm-hmm. So my intention was to keep it a little bit more compact and just focusing on, okay, what does this bay window do? Okay, when I change the glazing, what does that do? Rather than, oh, but this unit is a corner unit, so that changes. Oh, but this is on the top. It's a decision of deciding a method of how you want to conduct a study. But it could be a good addition, of course.
Okay. Thank you. I think it was really good overall, and I can understand the approach of taking the middle floor as something to be studied. It was just like interesting to see that why you staggered them, and I think it was really interesting and really nice. So thanks.
Thank you.
Any other question? We can take one more. Oh, we are running a bit out of time, so now we will carry on with Anaga.
Do you have any audio? No audio. Is it? Which one is it? Yeah. This one. Yeah, please, if that's okay. Thank you. Okay, let's try this. Do you want to plug that in?
Hi everyone. I'm dealing with the glass box typology, and the title of my dissertation is Breaking the Glass Box, which is a passive design retrofit approach for 24-hour comfort in the context of Bangalore. Just to set the scene as to where Bangalore is in the world, is about 13 degrees north of the equator and is a city in the south of India. Bangalore's always been a popular migrant hub, and the boom in the expansion of the city, however, came after the 2008 global recession with the increase in demand for office use. And the companies from the West outsourced their workforce to Bangalore, and this kind of has snowballed over the past decade and a half to the growth of the city exceeding the municipal planning by an entire decade. And the architecture of the office typology in Bangalore, however, has evolved from vernaculars and modernism towards a more globalized homogeneity over the past 3 to 4 decades, and the corresponding evolution in the organization of the workspace, however, has been a more positive outcome that has evolved from cellular offices to a more flexible and hybrid mode of working. And again, the office typology has evolved and adapted itself to the post-pandemic working environment. So that homogeneity has then resulted in this prevalent glass box office typology, especially in Bangalore, which is based on the Western notions of sophistication, and especially because these companies come from their parent companies are from the West. The architecture tries to mimic those architectural features, and the concern from design, which is the lack of response to context, translates to an environmental problem where design is in conflict with its climate, and the building stock makes up a significant, the glass box makes up a significant building stock in Bangalore, and hence demands a more critical look at improving the existing building stock rather than building new. Therefore, the architectural intent is to retrofit and to design a versatile collaborative workspace which is contextually relevant and to incorporate post-pandemic working. And the post-pandemic shift from a single organization workspace to a multi-use flexible co-working space brings in the aspect of 24-hour comfort. And the research questions in my retrofit approach looks at what percentage of the year can a building be comfortable in its free running state, and then what percentage of comfort can be achieved by coupling with the outdoor working environment, and how the outdoor working environment is made then comfortable through adequate shading and natural ventilation. The climate of Bangalore is famously known for its favorable nature, and the peaks in the summers are at 36 degrees, and the lowest temperature is at a mild 13 degrees. The high incident radiation prevails throughout the year, even with the winters having a significantly high radiation. This divides the climate of the city into broad seasons of summer, pre-monsoon, monsoon, and winter that are characterized by their diurnal ranges. Especially in the summer, we have a really high diurnal range, with the range being over 15 degrees and characterized by high dry bulb temperature and low humidity. And the pre-monsoon has a warmer daytime temperature but is high in humidity, which then brings in the monsoon with high precipitation and continues that humidity throughout the monsoon months. The winter temperatures are mild during the day, but the nights can get a little cold. Keeping the context of the city and the climate and the typology in mind, the retrofit is based on one such office typology, which is characterized by the mid-rise deep plan features. So the building that is of interest for me, that then serves as the site for the retrofit, is situated in a tech park. It's a corporate office for a financial corporation. The intended use of the building was meant to look like this in the elevation, with its clear glazing and transparent outward-looking working environment. But however, because of the lack of foresight, the usage now has become a more inward-looking environment, with blinds making the facade opaque both from the outside as well as the inside. Then this translates to the internal working environment, where this again was the intention, with favorable views towards the lakefront, and how the glazing was supposed to act in bringing a connect to the outside. However, is now a very close, opaque, inward-looking environment, with its daylighting being very poor and the dependence on artificial lighting. Also, the glass box is also categorized by its lack of natural ventilation because it is a sealed envelope, and the dependence on mechanical cooling is around the year. So then, just to summarize what the usage of the building is like, the density is designed for about 800 workstations, but post the pandemic is only in use for about 50% of the occupants at a time. And therefore, the resulting density is about 4 to 6 meters square per person, and high equipment loads because of the density, as well as lighting loads because there is a dependency during the day as well. And the construction is largely conventional, with the structure of the building being concrete and the glazing as a secondary skin is single glazed. Just to understand how the building performs, the data logger was installed for a summer week, and you can see that the AC set point was at 26 degrees, but the building performs even at the middle of the space about 3 to 4 degrees above the set point temperature, which is inefficient envelope as well as high demands for cooling loads. Based on the context and what the building can provide in terms of potential for design, a zoning strategy, a site level strategy was looked at, where we have restricted views to the north because of the context being too close, but the views towards the lake, which is the southwest, I'm sorry I'm missing a north on the image, but the lake basically faces the southwest, and so the southwest faces is towards the lake, and those views are then favorable for the working environment. The existing access is between the buildings, and I felt that there is more potential to round it from the lake and then use the empty space of the site that's then can become the front of the building. And the typical floor is a very deep plan, so then breaking the height to width ratio could be a potential strategy to be investigated further, because the skin is a detached element from the structure of the building. There's potential to deconstruct from the skin and then recess the facade to have the slabs act as shading in itself instead of adding external overhangs, and then additional shading if necessary. There was also an idea of looking at double height spaces, both as an architectural and as an environmental intervention. Then for these strategies, analysis was conducted in the dissertation over the 4 periods that were outlined at the beginning. But for this presentation, I am dealing with the worst condition of the hot and dry, which is characterized by its high dry bulb temperature, high radiation, and low humidity. And the strategies that would be required for comfort in this climate would be high thermal mass, appropriate window to wall ratio to limit solar gain, but also have maximized natural ventilation. Night flushing was of interest as well, because a large portion of the night time is in comfort, and solar control, of course, to limit the radiation. Shoeboxing study was then considered for 2 orientations. That was the southeast and the southwest, because it's a triangle. In the southeast, the base case of the fully glazed building was iterated upon with suitable window wall ratios and cross ventilation potential to ascertain what the depth of the recession from the facade would need to be for both the southeast and the southwest. Interestingly, because of the low latitude, the southeast and southwest were more or less symmetrical in the depth of the overhang that was achieved from the facade being recessed. Translating these properties into thermal comfort would then be investigated for different optimization strategies. So for thermal comfort, the workstation density was modified based on post-COVID regulations of 10 meters square per person, which then meant that the resultant occupancy would almost become half of what we started with. But that the hypothesis then was that if we are de-densifying the daytime, then could the nighttime be used to increase the number of people that are using the space over the day with the same building requirement. So then the equipment loads and lighting loads then followed based on that, and ventilation was maximized based on office regulations. The structure remained the same, being concrete. The external walls were tested with rammed earth for high thermal mass, and the single glazing was retained from the deconstructed skin that we had earlier. So I'm just trying to summarize a brief account of how the thermal comfort iterations were done, with the first case being the existing construction, but if it were to be in a free-running case with zero natural ventilation and without its mechanical cooling, then the peaks are going as high as 55 degrees. Of course, this is slightly exaggerated because it is a shoebox, but it can be expected to perform more or less similar to this. The working conditions remain true to what the existing conditions are at 9 to 5 p.m. occupancy and 5 meters square per person. And then the first case, which is the base retrofit performance, was with the proposed window to wall ratio ascertained from the daylighting studies, and then the occupancy and the internal gains that I had discussed in the previous slide. The depth was the flow plate depth was derived from the natural cross ventilation requirements of the width having to be less than 5 times the height, and that's how the depths have kind of staggered with the flow plate stagger of the existing building. And then the next case that we're looking at, which had the most impact, was adding shading with the facade being recessed and a regulated atrium environment that was then formed because of the depth being reduced. We can still see that during the late afternoons, although it's technically in the comfort band, the temperatures are at the upper limit of comfort. So then trying to see if those peaks could be flattened out further, a night ventilation, a night flushing strategy was then tested. So then with the night flushing, the daytime temperatures are largely in the middle of its comfort band. So then because of from the daylighting and the thermal studies, the environment is largely divided into 3 working spaces. One is the semi-outdoor, the indoor, and then the atrium environment. And the atrium environment was then looked at next for its cross ventilation potential and what it does for the wind flow through the building. The first image is the case that was arrived at from recessing the shading and what the planning would look like because of that. And based on the prevalent wind directions that are quite symmetrical in its east and west, double height spaces were then introduced on alternating group of levels to allow for that flush of wind through the atrium to ventilate the space. So that's how I'm trying to deal with the stratification of temperatures to prevent hot air from accumulating across the levels of across the upper levels of the atrium. And the third part of the 3 working environments was then the semi-outdoor. The shading limits was then established based on the proportions of the opening for the semi-outdoor space for the 2 orientations in concern. And because of the high radiation throughout the year, shading was considered more or less throughout the year for both the orientations, but for different times of the day, with the east being mornings from 8 to noon and the southwest being noon to 5 p.m. from noon to late afternoon, basically. So based on the shading proportions, an adaptable shading device was designed that uses the vernacular terracotta roof tiles that's local to the region and are repurposed as louvers that form a system that can then be slid between the workspaces based on where the person's working. And the impact of that device was then looked at on the internal space to see if it was causing any adverse effect on the daylighting, and then the impact on incident radiation on the work plane of the outdoor space. And the cases here are looked at with only the overhang, which was formed because of the recessed facade, and then the addition of the vertical shading and what the impact of that is. And because they're adaptable and the occupant can slide it, it would vary across the depth of the workspace based on where the occupant was. And then the resultant UTCI on the facade was about a delta of 3 degrees in the worst period of that day. So based on these analytical work, a flexible planning strategy was then made by designing for the 3 environments that were discussed earlier, the inside, the semi-outdoor, and the outside. In this slide, we're looking at the indoor environment. Because it's a flexible co-working space, the different proposed occupant groups are looked at in terms of single working, smaller groups, larger groups, and social spaces. And similar density is achieved in the semi-outdoor space so that the occupant can couple. Basically to say that the outdoor space is not an additional working environment, but it's a spill-out space from the density achieved with the inside. So with this planning, how the space works in the 24 hours is then looked at here. So in the time slice for that day, between early morning and mid-afternoon, when the operative temperatures are in comfort, the occupant can basically work throughout the 3 working environments. So the workspace is coupled with the outdoor, and natural ventilation is in place, so all 3 environments are comfortable. And then the period when the outdoor temperatures are at its peak, that's when the occupant would need to decouple from the outside, and that's when ventilation would largely occur through the atrium. And the outdoor, semi-outdoor working space is proposed to not be active during those hours. And then in the night, for especially the summer period when we're looking at night flushing, because the nighttime outdoor temperatures are comfortable, I propose that the occupants then empty out the indoor working environment, work in the outdoor, so that the envelope can then be cooled of the internal gains and ready for the next cycle of the 24 hours. So basically capturing how the space works in its coupled working condition with the natural ventilation and the thermal mass absorbing the heat during the day, and how the outdoor working environments act in bringing in ventilation as well as some vibrancy to the space, and then in the night with the occupants outside and the thermal mass releasing the heat but then being ventilated through the atrium as well as the outdoor space to cool it for the next day. And then looking at the impact of this construction in the retrofit, I'm comparing the existing building's embodied carbon, but just as in its A1 to A3 stage, for just the superstructure, because that is the scope of the intervention. The existing building is largely concrete glass and some aluminium for the cladding in portions of the facade. So the highest proportion of the carbon demand goes to carbon, and then glass, and then aluminium. And then I'm comparing the proposal as a new build to see where the change in, or what the change is in the carbon, but the proportions of the material used, 80% still remains concrete because the same amount of structure is being used, and there's some reduction in the glass because of the glazing being used both in the atrium as well as the outside. There isn't a significant reduction in the usage of glass in the building, but because of rammed earth, the aluminium component has some is replaced by some amount of soil and aggregates. But then looking at this proposal as a retrofit would then completely eliminate the demand for concrete because we're using an existing structure and the upfront carbon is offset by 80% because of that. And the amount of concrete that I'm demolishing in the creation of the atrium or the removal of the slabs are reutilized in the rammed earth. Because the rammed earth that I'm proposing is made out of the debris, and that's the advantage of using in situ construction on rammed earth. And then what's the consequence on operational carbon is that the whole cooling demand is completely eliminated from the building, but there is some increase in lighting and equipment demand because of the 24-hour workspace. But the cooling demand is 75% of the energy demands of the space, and that's eliminated entirely. Just leaving you with a visual of the space. Thank you.
Thank you, Annika. Who wants to start? Joanna?
Thank you, Paula. Maybe I can say a few words. Thank you, Annika, for your presentation and clear visuals of the project. I'm going to be very brief. I think your project is responding to a super urgent need, which is the retrofit of these buildings, which are new buildings now, reasonably new. So very well picked. I just, reflecting on everything you presented, I would just take one step back, and I think there is a little story missing that you are addressing technically, but in terms of design approach, I think it justifies the design approach, what I'm going to say, that I missed in your presentation, which is a small intro saying that the importance of semi-open and outdoor spaces in the new working cultures of today. You are not retrofitting a building for the same office activities that were there 10 years ago or 20 years ago. So we work in new ways now. We expect different qualities from a working space than we expected a couple of decades ago when these buildings were built. Then in addition to that, all the notion of adaptive comfort and adaptive strategies, and the notion that comfort is something much more wider and wide notion and quite acceptable, supports this new architecture that we have to develop. So this is more intro. I think it's very important because it justifies a lot of what you're doing and the importance of it. And this new architecture will come with a lot of environmental diversity. And that's what you are creating too. So I think that connection with the culture and the moment we are now and the new office, but not just that, also the new notion of comfort, new, which is not new, but for the world out there, it's reasonably new. It's something we need to underline every time we can. And then also in a place of super exuberant and natural environment. I mean, Bangalore is a beautiful tropical green place that tree grows anywhere. And super fast. So you are reconnecting people with something that has always been there for them and in their office spaces is lost. So I would really make those points because I think it brings a lot of value to your work. Then talk about the design, just a couple of comments. I appreciate very much the way you are designing new technologies. I mean, like the screen, the shading with the old terracotta tiles, not old, but traditional, let's say. You are creating new building components, offering something for the industry that can be replicated and reapplied over and over again. So I think that's quite a contribution of your project. A more critical comment that I have is by looking at the spaces. I quite like the plan very much and the section and the way the several spaces relate to. I would like to see more environmental information on the section, not just the arrow of the wind and this is a zone, this is another, but temperatures at the same time, what is happening where. A bit more data that you have. You had it in the graph, you could have put it in the section. But the critical comment is about the facades, the walls. Looking at the relationship between spaces that you establish, do you really need so much opaque wall all around the plan, like now, to achieve the thermal performance? You might need, But I will question that because, the plan is reasonably deep, not very deep. You have mass on the slabs, mass on the floor. Could you have a more open interface between the balcony and the real internal spaces so that at some points there could be only one, literally, and perceived as one space. But it seems you have quite a lot of solid walls. There is a reason, I'm sure, behind that. I didn't really follow. So I would challenge that aspect of the design, but you don't need to respond. That's just a comment. I stop here.
Thank you for your presentation. It's always good to change climates from the European ones back to the humid ones. It's quite a challenging climate, quite humid in a way. You've explored a lot of different solutions and you approached the angle of making this building work passively 24 hours, which is very interesting. I was wondering though, you mentioned one of the key strategies that you included and you studied was thermal mass and the night flush ventilation. Cooling down that mass at night depends very much on the temperature at night outside. Since I come from Indonesia, I wonder if in Bangalore it's quite the same. The temperature doesn't vary that much. So I was wondering first, what was the potential for night flush ventilation in Bangalore?
The potential is largely in the hot periods because of the diurnal swing is over 15 degrees. So that was the potential to incorporate it, but it doesn't translate throughout the year because it's obviously necessary only in the hotter parts of the year. Okay.
Thank you. I was also wondering, because all these buildings are these glazed buildings in India, in a lot that we see also in Indonesia or in other parts of the world. There's somehow a misleaded idea of progress where people want to mimic a behavior that are not very local in a way. The idea of a building post-COVID, an office building where people would adapt and instead of pressing on a button, I'm sure you've thought about that, how it happens. And it would have been good to hear a description of how going to the office in such a building would be. And at different times of the day, or I don't know if the monsoon changes a lot of things, but then how, if say I'm in a meeting room, can I have it in the semi-outdoor? Should I have it at the center of the plane? Or the periphery of the plane reserved to more permanent positions or temporary positions? How is the life in that office actually happening across the seasons? And what's really offered to me? What can I really adapt? I saw the terracotta and shading device. I thought it was, at first I was thinking, okay, well, why did you just put it in some places right in front of the window? Then I realized that the sun path in Bangalore must be quite narrow in a way. It should be, the sun is quite vertical. It still comes from the south. You're still 13 degrees away from the equator. But it's quite constantly in the afternoon. You'd have really horizontal sun rays hitting the windows, right? So in the end, those shading devices can also be fixed in a way. Just the adaptation happens on the angle of the louvers or the angle of the terracotta. So quite clever way, but then I joined Joanna on asking the reason why you chose a window-to-wall ratio that was quite constrained in a way.
It was based on the daylighting requirements for the office space, which was significantly lower because of the use of screens, and that's what pushed me to have a more significant solidity.
Okay, and lastly, I wonder if it's always good to make. I mean, I really find it interesting to make the exercise of thinking of a 24-hour passive building in the tropics. Do you see any way that this could work in a hybrid mode? Is air conditioning completely incompatible here, or how do you see that?
I haven't considered. Because from the outset, the objective was to eliminate mechanical cooling. That's not a consideration at all. But I do foresee some peaks in in the worst of days that I think would need more wind speed with ceiling fans and keep that movement going, but I haven't considered cooling nodes at all. But if the question is it possible to add it on in a later stage, then maybe, but I haven't considered it in the scope.
Yeah, and the last thing that I thought was very interesting is the way you justified the demolition of the atrium. In the end, these structures, whether good or bad, are already built. They're existing structures, and for you to study first what you need to change or add on them is a really commendable way. And so you justify the demolition for the atrium, and then you reuse the broken concrete for the round earth extension. Yeah, so really great.
Thank you.
Thank you, Annika, for your presentation. You're dealing with a very contemporary problem, which is the retrofit of our existing buildings. Ultimately, by 2050, 80% of the buildings that we will have by 2050, they're already built. Not only is the retrofit, but it's also office, which over the last 3 to 4 years with the pandemic, it has been reshuffled how we work, what are the flexibilities that employers offer, how is this culture, this new culture that some companies are using to attract employees, how do we respond to that in the shape of a building? So I think in terms of the topic, I find it fascinating and very interesting that you have a combination of the retrofit with workspaces that respond to this new need that is only 2 to 5 years old. Sorry, I just realized that I was not on the microphone. However, I would have liked to see a bit more, and I think you have thought about it, but it's not visible on the presentation, how these 24-hour needs that you have for your building, how these changing patterns in occupancy, how the climate variations that you have across the year, how those translate into the use of your building. Where are people supposed to be, or where are people likely to be during a winter day? When are people likely to be during the monsoon season? Because you explained to us one of the seasons that I think it was the worst
Summer,
one,
yeah.
with all the analytical studies, and I totally understand that doing analytical studies of that depth for all the seasons, it takes a lot of time, but probably conceptually, you know more or less how things are likely to be. So I think it would be good when you present it to cover slightly at least the other seasons, even if it's not in such depth as the one you have, because I'm sure that you have thought about it quite in some depth. And probably in relation to that, if you could have, and this is beyond what you can do, but images that illustrate this for us to understand or to actually relate to how that building is going to be used, it helps build up your narrative on how you're reshaping an asset or a building that already exists that is terribly unfit for purpose, as you have shown us, how you're adapting that to the new post-COVID reality of workplaces. I don't want to extend too much, but I think overall you have tackled the problem with very thoughtful architectural mindset, like you're sorting it out with architectural strategies, and that is very commendable to see. So yeah, well done.
Thank you.
I was just thinking that for the developer, the 24-hour work is profit, but for us, it's a hypothesis that comes to mind as researchers by an understanding of the climate. So that you're looking at the climate you're experiencing as an inhabitant and so forth, and you realize that certain conditions that take place at certain times of the year are amenable to an understanding of comfortable existence. So, using general terminology, which then can be specified. And this is why you keep getting comments that show that somehow you did not approach it as a researcher, but somewhere in between the developers and then not the developers. So I think there is a little gap there in the notion of the hypothesis that actually leads us as researchers to think that the outdoor can be an extension of the indoor in terms of the workspace. Now, that of course will not be bought immediately either by potential occupants and or the developer or whoever is paying for it. It won't unless you sell it. So there is the discovery of it in our terms and then the promotion of it. And I think you need to think a bit more and express the directions and the potentials, because there is a project there which research somebody wants war, football. Anyhow, I continue. If you don't mind, but not very long. So I wanted to point this out. Then there's something else that occurred to me as I was listening. You used the words shoebox. I don't like that. Okay. I mean, we use the word shoebox when we do exercises, when something is introduced in the tools that, in order to make it palatable, then the people doing this, they call it shoebox in the sense it's simple. I mean, your starting model is not a shoebox. A starting model is a model you understand, is a simplification of the existing building in one of its manifestations, because there could have been several. So you choose which one you wish to make as your starting model, and then you improve it. Yeah, I mean that's quite important. So it's a building as is, and then what is the outdoor space that is near the building that comes into the 24-hour operation? You gave a clue there. You say the outdoor space is a spill out, which is, yes, it's a valid point, but that spill out has to be organized so that it looks natural, so that naturally the doors will open between the core space and what was before a transition, and they will become one, and then it will be a spill out. But in similar ways, and I think it was pointed out, you need to think about all the combinations that there will be. Because having outlined all the combinations, then you're able to strengthen your case, because repeatedly certain things give certain possibilities, or not, as the case may be, in which case there are different strategies that need to be applied. And it's only when you do all this that your story then appears immediately believable and promotes itself, and then it happens. So I think you need to reflect on this, because there's an opportunity to illustrate the life, the kind of working life that this could entail, which can be a very interesting one. And Olivia started to imagine, the trees having grown, and it's very tropical, and he loves it. See, I think Joanna was sharing that vision as well. I mean, we could all share it if you try to. Whereas when I look at some of the slides that you showed, although elaborate, that look a bit empty, unoccupied. So I do hope that although there is very little time left, that you will be able to insert certain suggestions that give a flavor of what you could do with this.
Thank you. Florencia, do you want to carry on?
Yes, of course. I thought you were, thank you very much. I thought you were very clear. This topic is so necessary. I think that I'm just going to build up on things that were already said. I think you have worked for a lifetime with this, because it's really the step, the extra step that we need now in so many buildings, in so many cities. I also wanted to congratulate you. I think you have it very well. Your point is very well proven with the pictures you have, which is really not easy to do. You managed to get very good pictures of all the shadings that were closed. And I tried to do that for a while, and it's not easy to document it. So I think that that's really good for you. You were very precise in terms of inputs, which I thought was great. But I have to agree that I think that you have to sell better that intermediate space. I actually noted that in one of your daylight simulations, you left that intermediate space, you left it out of the simulation as if it was not a working space. I'm not sure whether it was an intermediate space or an outdoor space, but I think that in the concept itself of leaving it out of the daylight simulation, you are saying that this does not belong to the workspace. But actually, it should. Actually, you need to be yourself convinced of how good that outdoor space is to work as well. It's very positive in India, and actually that's already happening. We already had a project like that in Paris. It's already happening in Europe. So let's hope that it moves to other parts of the world in the same way that the single envelope seemed to be something that was coming from the West. Let's hope that these ideas also come from the West. And as a last comment, also to strengthen the fact that in these kind of buildings, the envelope used to be a line of glass. And now what you're proposing is this is a full space. This has different layers. This is not just a line of glass. This is not just the indoor space that is controlled mechanically versus the outdoors. This is now a full gradation of spaces where we can work, of devices that you can use to adapt. And I also agree that it seems that the wall is too opaque, and you yourself said that you're using more daylight, you're using more electric light than before. So that's just an adjustment to do, because I think that the concept in general is great. So yeah, I think that you just need to put more strength in how good that outdoor space is to work and to be, and how it's going to be a different thing moving forward.
Thank you, Florentia. I have little to add. I think it was a very good presentation, and I think you were quite courageous in choosing this topic. Because it's really complex, and there are lots of issues to tackle. And I'm sure if you would have more time, you would be able to tackle them within the same depth. However, I think it was a very clear presentation, and it demonstrated how you used the SED methodology and the tools available to improve certain things. You were very clear from the beginning what are the main problems, and also what were your objectives, and then at the end also showing the reduction in carbon, operational and embodied. And well done. Thank you.
We have 3 presenters now. We're going to go in a row until just before 6, hopefully. So we will start the second part of the afternoon with Jai Wei, which is going to talk to us about his project on affordable housing in London. 15 minutes, Jai. Okay. Yeah?
That's okay. Could I start?
Is it working? Can you tell
Hello?
us?
Oh, yes. Yes. Good afternoon, everyone. I'm Jai Wei Tang, and my topic will be the generative prefab affordable homes in London. And my whole presentation will be separated to 3 chapters, which is the introduction and background, and then the unit generation, and finally will be the estate formation. And first, for the background, because of the population boom and London is now facing a housing crisis. The policy like the affordable homes programs or the London plan is released to relieve this situation. And my project will be focused on how to create an affordable house estate for people on low incomes and for young people, help them to afford their first home. And the location will be in the East London, Royal Dock, North Woolwich area. And for the site, the transportation, we can see that there are DLR station and the bus station surrounded in the 10 minutes walk distance. And for landscapes, there is the Royal Victoria Gardens, also in the 10 minutes walk. But for amenities, there is few restaurants and stores. So for the climate context, in winter, most of the time is out of the comfort band. And for summer, there are several days also out of the comfort band because the overheat problem. But in the future, this kind of hot summer maybe become usually situation. So this is also what I would need to concern about. And for my house type, the prefabricated house is always the first choice for the affordable house program or the social house program. From the Le Corbusier's mentioned domino to the Y-cube from the Rogers, they are all using the prefabricated technology, which could be quickly assembled and relatively affordable, and it also low carbon emission and easy to recycling. And for many prefabricated house, the units just stacked together like the photos showing on screen. And inspired by the Habitat 16.7 by Safdie, I'm starting to thinking why we always need these box-like blocks. Could we have a flexible plan? And could we also design this kind of modular house based on the environmental parameters, like the daylight, temperature, and ventilation? So for this design, I will focus on how to generate a prefabricated modules based on the environmental parameters, like the illuminance, direct sun hours. So for the first part, units, for the second part, the units generation. According to the regulation in London, that the interior areas of the dwelling is related to the bedroom, the number of a bedroom. So for my flats, I will design 20 to 28 square meters per person, and I will design 1 bedroom, 2 bedroom, and 3 bedroom flats. And this flat consists of bathroom, kitchens, and the rooms like this. And for every rooms, I set a standards. For example, the kitchen it need more daylight, so it will be 300 lux, and the bedroom is 200 lux. And according to these standards, I have my draft plan. So we can see one side of the room is faced outside, and another is faced corridors. Then for the material and the structure of my flat, I'm doing a case study on Meredith Grieve, which is a prefabricated house, consists of the solid timber, and it's complete within 49 weeks. So my material selection will also be the timber prefab structure, because it have a good sound insulation. Because my site is quite close to the London City Airport, so the sound insulation is also a very important point. And the timber also have a good thermal insulation. This is the structure of my flat. It will consist of the CLT slab, timber panel walls, and double glazed windows. These all materials have good R values, which to keep sure the thermal performance is good. Then these are all 6 types of my flats. Yes. So before the flats combine together become the whole buildings, the first question I need to solve is ensure each apartment have good interior parameters. The objective is to keep sure every room's SDA is more than 15% 300 lux, and all the rooms is in the comfort band. And so to improve these two objectives, I have three methods, which is to change the floor plans, add the extra window, and add the solar control. So first, I doing the simulation on the base model with free raining, which is no cooling and no heating. And for the light condition, I do simulation of 4 orientations. And the result is on the right side. And these are the result of 6 different types of my flats. And we can see in the results that the light condition is not so well for the both base model. Many flats SDA is lower than the 15%. And then for the thermal comfort of the base model, we can see in the summer there is also overheat problem. Some of the days it's out of the comfort zone. But in the winter, there is only 1 bedroom is out of the comfort zone. And these are the thermal comfort result of the 6 flat type. And for the percentage of time in the comfort band, in summer we can see it's only about 18%. So it's not so well. And if I turn the heating on, then the energy consumption in the winter, it will be around 20 to 25 kilowatt hour per square meters. So the conclusion of the base model is that some rooms SEA is below 15%, and there is overheat problem in summer, but the energy consumption in winter is acceptable. So I need to solve these first 2 problems. First, I change the floor plan. For example, this is a 1-bedroom flat duplex, and I remove these walls, let the sunlight to come inside, because the wall is block all of the sunlight, which the bedroom behind don't have enough sunlight. So remove some of the wall will improve the light condition. And I also add the extra window to help more light to come inside, and also help the natural ventilation. And then I also add the solar control to block some of the solar radiation in the summertime. So the result of the improved model, we can see that every 6 flat, the SDA is more than the 15%. And the percentage of the percentage of time in the comfort band is all around 92% to the 96%, so it's quite good. I also have some adaptive design for my flat, which means the users they can choose some of the elements, like the balcony. I have 3 options for them, and they also can choose whether they want the extra windows. Because some of the room types, they don't have this kind of light problems. They have enough daylight, so they can choose whether they want extra windows. And they also can change their floor plans. And another thing for my modular flats is that after use for maybe several decades, it's easy to repair and recycle because it's all modular timber slabs. And the chapter 3 is the estate formation. Now we have the units with good interior environmental parameters. So the second question we need to solve is how to ensure the apartments won't interfere other apartments when they combine together. So I do the analysis in 2 aspects, which is the light blockage and the exposed envelope. First, when we just combine these flats together, some of the flats maybe block the sunlight from others. So I need to figure out how much space is needed between these flats and how high it will take. It will block others' daylight. So doing the analysis on this, and the result is that we need at least 4 to 8 meters void between two flats, and the maximum height of the outside context will be 7 meters, which about is 2 floors. And another thing is the exposed envelope. This is one of our flats, and one side is faced to the corridor, one side is faced to the outside. And there are 4 other sides which may be connected to the other units, or it may be just a void. So I need to consider determine how much area of the envelope could be exposed. And I have analyzed on the time of in the comfort band in a typical winter week. Then we can see the scenario 1 and scenario 11 have a very bad thermal comfort performance. This is because the scenario 1 have 3 sides exposed, and scenario 11 have 4 sides exposed. So too much envelope exposed make the heat loss increase. So when combined together, I will reduce the exposed envelope, make the flats to connect each other more closer. Then the third question of the whole estate is that how many apartments and other areas do we need? And for the housing density in the London, it's about 31 to 345 dwellings per hectare, and for the area of Royal Dock is 15 to 110 dwellings per hectare. So I selected my density as 150 dwellings per hectare. It's about 350 flats. And I also designed the outside space for the adults and children. And the outside space consists of the outside components like the platform, corner terrace, and they will combine, connected to the flat modules, and generate the whole estate. And these are the quantities of different components. Sorry. We will have 40 flat A, which is the 1-bedroom rooms, and this we will have also 40 1-bedroom duplex, and these are all these numbers, the quantities. Sorry. The number of amounts of each type. Yes, the numbers of each components. It will have 340 flats, and I don't calculate the outdoor modules.
How many units do you plan to put?
Yes. So for the whole estate, we'll have 3 areas, which is the tower block and the low-rise block and amenities. And from the tower block will be located in the top. It will about 5 floors, and then is the lower-rise block. It will occupy 2 floors, and the amenities will be at the bottom. It will have 2 floors. And so for the tower blocks, we will have a core in the center of the tower blocks, and the flats is around the core, and there is elevators and stairs in the core. So each core will connected to approximate maybe 8 flats per floor. So we'll have 5 cores for the whole estate. Yes. Oh, I will go through faster. Okay, sure. So the first thing is I need to determine the location of the tower blocks. So I do the daylight simulation. Because the tower block is on the top, it will affect the other levels. So I find out the best location of the tower blocks, which have the least affection on the other low-rise blocks. So these are the corners location. And because some of the part it still have a very bad light conditions, so I reduce this space from the whole boundaries, which means these two voids will not generate any units. Then I first generate the low-level blocks, and I also do the simulation of every rooms. Then I generate the tower blocks. These are the final estate, final residential part of my estate. Then I also add the levels. So this is the final rendering of my whole estate. Thank you. That's all. Thank you. No. Sorry. It's my fault. Sorry.
It's working, yeah. But half, maybe?
Thank you, Joey, for the presentation. You have a very interesting approach, a very different approach. I think it was very clear the presentation on all the graphics, how you have explained us, how you have taken us through this very complex and very technological approach. So that's commendable, because otherwise I think it would have been much harder to follow all the iterations and all the studies that you have done. I think it would have been interesting for someone coming new to see your project to get a little bit more context on the problem that you're trying to solve. I think we're all very aware in general of the lack of housing and affordable housing in London, but it would be good to put some more figures or to give some context. What kind of housing do we mean? Is it for one person, for two people, for three people? What is the family that we're trying to accommodate there? And what do we mean by affordable? Because that somehow forms the basis of what you then plug into all your analytical studies, no? So if you could give us some more context about that when you present it next time, it would be very helpful. Then there's a lot of technical process that you have gone through, but then we miss at the very end, once you reach the result, what are the qualities that your spaces offer, no? So you've gone very quickly to that through that last image, which is an aerial view, but it would be interesting to see what are the qualities that your spaces offer. You've talked about optimizing for daylight, optimizing for thermal comfort. You add some outdoor amenity spaces, but then to a person living there or to the persons that need this affordable housing, how does it look? What does that mean? But I think overall it's a relatively different design approach. I would focus a bit more on clarifying what are the inputs that you put into this approach, and then what is the result that you're getting out, and how that solves the needs that you identified. But thank you.
Thank you.
Thank you for your... So, first of all, it has to be said, the presentation is a very high-quality graphics, interactive, very entertaining. It's highly technologically oriented. So that's quite pleasant to see. But, you know, with all these tools, all the technologies that we're using, optimizations and all that, it's what you want to be careful at is not to be judged or to fall into the crack where the reason why you're investigating architecture is to use the technology. You'd rather be very clear on what you're investigating, what Rafa said, as in define the problem that you see and you're trying to address, and then the technology is only a mean to proceed with your reasoning, right? Because you're slightly on the verge of, we don't, sometimes, you know, it's nice to see them, but at the same time, okay, there are some questions about what you're really trying to do here. So I'm sure you've got a lot of thinking process behind all of this, and but I think it would be good that you make it very clear on what you're actually addressing. That's a very, very key point. Because we don't want to be criticizing the technology. We'd rather just have things in order and the technology at the service of the logic. Same as Neva, Elif earlier. I think although prefabrication is, maybe it sounds obvious for those who have studied it, there are a lot of very key elements why it is low carbon. Why should one think about prefabricating elements? Maybe they're obvious, they're not to me. The low carbon aspects, all the savings in time of construction. You mentioned 49 weeks for the Murray Grove example, but then in comparison, maybe just put the comparison prefab against normal traditional construction. And then in prefab, there's a lot of constraints that come with prefab. Airtightness. What kind of material can we actually consider in prefab? Are there available solutions in London? What kind of structure fits this kind of boxes? Do the boxes just stack one against another? Is there a steel structure? Is there a concrete structure? A timber structure? And then the assembly between the units, is it airtight enough to respond to the need for airtightness in the climate of London? Especially when we see the result of your optimization process at the end, where we see all these boxes stacked. We can see the amount of exposed area. It's a very porous design. There's a lot of exposed surface, right?
Yes, yes.
So we're just wondering, how do you optimize the heated envelope? How to we want to see how you resolve those issues, I think, because otherwise there's a lot of heat loss, even though they're opaque surfaces. And also in between all of this, I think I would have liked to see the circulation areas. How are these units connected? Because they are individual units or double units, but then is there a common area, a shared area, circulation areas, and how do they how do you lay out the plan according to orientation, maybe, something like that. But those were the comments. I hope they're helpful.
Yes, thank you.
Thank you. I thought the visual presentation is excellent, and you should continue working in this way in terms of showing things. My problem is with the things you're showing. There is a problem there. See, in terms of research and in terms of affordable, I think it was pointed out there is no definition of affordable that you have given. I liked the approximation somewhere. I think I saw you said relatively affordable. Yeah, I think that is really smart, because in the case of London, it is the only thing that can be said. But now, perhaps we can't define the affordable that well, because we're not dealing with pounds here, but we can definitely define the environmentally performing, and that is the problem with your data. That on the one hand, I think I picked up a U value of 1.1 for glazing, yes, which you seem to associate with double glazing. And then at the same time, you don't seem to be reaching any more than 50 comfort, what is it?
The percentage
50%,
of...
50% comfort hours. Now, these two immediately ring bells in my head, because I know for sure that we can achieve very high percentages of comfort hours in London, even more so if our glazing is giving us a U value of 1.1 instead of 2 or higher. So then the bells are ringing, and then I'm trying to see what have you set as standards, as targets, as calculations that you have done, which you're comparing with some previous one precedents, but I didn't find any. I didn't find any, and that is a huge problem in terms of research. You know, the chain is broken, and my only hint there is the 50% comfort. It must mean that the buildings are no good, and then, you know, like Olivia would look around and say, why are they not as good as they should have been? And maybe it's the exposure, maybe it is, after a while, I don't know what it may be. That is a problem.
Yeah.
And reconciling that with the excellent visuals is a problem, because you can be a dangerous guy, you know, sort of showing something that looks fantastic, and then, you know, the performance is not up to it. So, well, there are some very easy ways of looking at this, and you can deal with them very quickly, I hope, because in the course of the presentation, lectures and so forth last year, we looked at lots of housing case studies, so there are lots of numbers that you can associate with different typologies of housing. And that's based on case studies that we did as building study in term 1 in previous years. And we have a summary of this in a paper, in a journal paper with Jorge, where you can see not only the individual characteristics of certain case studies, but also the trend by plotting and the correlations that we have established. And in addition, of course, you have things like LETI that give suggestions, recommendations, and calculations. So then these things become numerical data against which you can compare yours. You know, and then you can know where you are. It could be, in fact, even possibly that you have done very good performances, that your cases have very good performances, just that we don't know how to read them, because you haven't given the magical entry point. Like, for example, if you gave us the Hitler's coefficient for your units, we could, or some of us could, convert those into equivalent. So, for example, I know that anything that's below 1 watt per square meter per degree as a Hitler's coefficient is pretty good. It will lead to a space heating load of 10 to 15 or thereabouts, but also to possible overheating. I know that. So then, you know, you could go and look at your cases and see what kind of range of Hitler's coefficients they have. Or if, let's say, their window areas are too large in some orientation. Well, that in itself is not very helpful, because you have assumed this very low U value for windows. 1.1, yes. 1.1 will be unaffordable, relatively unaffordable. So I do hope that you will take the time, a couple of hours or so only will be sufficient to be able to look at this point. That's what I have at the moment.
Okay, thank you.
Okay, Flo, do you want?
Yes, of course. Joey, I think, like the others pointed out, I thought you were very methodic in the way you were trying to approach the problem, to make sure that all the units are good enough and that all aspects were considered. and you actually thought of variations in the typologies and outer spaces and how to adapt it. And I think that that way of thinking is very good. But I also see, I share the same concerns that were pointed, especially because it's very difficult to judge. You show one slide where you were comparing the relative differences between all the performances, and you were pointing two that seemed to be the worst cases, but they were actually very close to the other ones. And I'm surprised to see that everything you're showing there is so similar compared to the variation you're showing in the end. So it's very difficult to understand how to assess that performance. And something else that makes it very difficult is that we don't understand how everything you variated in your simulations translates into architecture. What does that mean? Does it mean a certain window to floor ratio? Does it mean a certain window to wall ratio by orientation? That was very difficult to grasp. So maybe it's just a matter of clarifying everything and to just put it on paper, but it's difficult to assess how good or how bad it is, because in terms of architecture, we don't have an anchor, and in terms of performance, the results are also difficult to assess. And you're also mentioning some data targets that you said that you had set. I remember seeing 100 lux, 200 lux, and 300. So, and those are based on what? There are, for example, European norms to base targets. That could be another lead. And I also share Rafael's point in the sense of in which way the space you're designing is nice. How do you like those spaces? How do you live in the spaces you're designing yourself? I think that's also important, because in the end, you design to enjoy, right? To have a space that is livable, that is nice. And how do you like what you are creating? Because you're showing many optimizations, very much computer-based, but is that result something that you like, something that in the indoor space can be enjoyable? And I agree that these are things that maybe just need clarifications, and maybe they're already good, but because they were not shown, it's difficult to understand. Thank you.
Thank you.
Thank you, Flo. Jaiwei, I would like to say first that in the whole year, I think it was your best presentation. So I really commend you for that, the effort you put to make it clear and focus within the time without rushing. Excellent, thank you for that. I have two comments about the project. One is, did you say at some point 25 kilowatt hour per square meter annual?
Yes, the
You said
heating
that.
energy consumption.
Yeah.
Yes.
And you said that's acceptable. That's maybe very high. Just a minor point. I mean, it has to do with all the discussion about how to understand and compare and value the performance of your units. So I would not accept 25 to today's standards, a new project, prefabricated, with all the opportunities you have, possibilities in terms of insulation and other design strategies. So you should not stop there, unless you say this is my worst case and it happens because. But the majority of the units are within passive house standards or below, because that's what you can achieve. Because the point is, you do all this, let's call it sophisticated process, and then you come to a result which is maybe the double of what you can do, just oriented properly, not exposing too much, having the right window to floor ratios. Then why are we doing this? I'm going to go alongside the comments of Oliver. What can we take from this process? So I will look at this number carefully. I do have one question, quick question. The first parametrization generative process, what is being varied there? Is it orientation? The first one, not when you put into context, but when you have only the plans.
You mean?
Before that, before, the very first parametrization. Are you testing the orientations?
The interior one or the whole estate?
When you tested the individual units,
yes.
the very first generative exercise? Is it orientation that is varying? Yes, this one.
Yes.
Is it? It's orientation.
Yes, it's for orientations.
Okay, because that process, maybe the generative and the script helps you to do a bit quicker, but this is something you don't need a parameterized model like that, no? That's what we normally do, just turning the model. Is that correct?
Yes, just turn around the models and then do the simulation.
Okay, because the point is, we are, thank you, making the adjustments to, maybe to make it more, not efficient, but logical or convincing or contextual even, and even tuning some of the performative aspects of it. I'm afraid I'm not being too clear, but the point is, at what point do you stop the generative process and you come with a different, maybe, not a different, but a new approach where you look at it and then you adjust it, and that's the final product? Because I understood this is a result of the optimization, correct?
Actually, my script just generated maybe 50 results. Then I selected one of the results from these all.
And you selected based on some criteria?
Manually, I just think, maybe this space could be a playground, and this space is more, have a better views. So I just selected manually.
This is very, very important what you're saying. So just make it clear that in your document you show that, because you did do what I was thinking. You look at it and then critically with qualitative aspects maybe you come and decide. And maybe not just choose, but also work on it.
Yes,
I think that will be a next step. Thank you.
Thank you.
Thank you, Jaiva. I agree that it was a very good presentation, and thank you for not exceeding too much the 15 minutes, because a few days ago you had 85 slides.
Yes,
so,
I reduced many of them.
So, and I'm sure that many of the things that were said here, I know that you have considered, like the LETI standards and also the illuminance levels, references to those, or even, compared with the book where the SED case studies is. But you had, of course, to select some of the slides. I think, nevertheless, it was very useful, the comments you got here, because it's the way how you need to tell your story in the book, maybe only shuffling things and highlighting, like just taking this last comment from Joanna, it's about the environmental criteria, but you manipulated a lot during the process, changing your script during your working process for including architectural criteria as well. And I think this was not very clear today, and so maybe you need to highlight those. But but thank you very much. It was an entertaining presentation. Thank you.
Thank you.
I'd like to add something which I think applies to other projects as well, and on which we need to work actually in the program, and that is that we're using simulation, thermal simulation, in order to be helped in the way in which we design, and we expect that will be the case, and that should be the case. Whereas here, what we have identified as a problem is that simulation has been used, but instead of helping, it appears to be confusing us. Because you see, you could have designed a scheme that is guaranteed to have a meaningful performance on average without doing any calculation of your own, just by basing your designs and being able to express them in a numerical model that is very similar to a numerical model given to you by standards, the building regulations, LETI and so forth. Yeah, we can do this today. We couldn't do it some years ago. So if you are to design yourself, to learn from simulation, then it means you're going further. And I think where we're getting problems there numerically is in the area where there are inputs that you have not considered. Like, for example, the set point temperature maybe is being considered dynamically by the model, which then affects the result. So then you're losing comparison with some other result, with the standard that you wanted to follow. It could be the heating hours, which again, maybe you didn't consider, you didn't change, but numbers that are published consider a particular schedule. It could be when there is a heating season, that a start of counting the heating loads and stopping counting, which again might be there. The software has to put values, otherwise it will not calculate, and we don't know what they are unless we look at them. So it's very important to have a go at this. If you want to play it this way, if you want to make simulation work for you, then you have to take responsibility of all the inputs. Therefore, all these become questions, and they are answered in this way, and then they give that result. That result is based on different assumptions than some other result that was gotten differently. We can't compare them, you know. And then everything is clear. And as I said, you always have the option. We don't calculate. We make it simple. We just follow the precedent.
Thank you. Thank you.
Surabhi, please take your position.
Good evening, everyone. My topic for dissertation is designing a center for sustainable living, rekindling interaction between man and the build. So what I literally mean by Center for Sustainable Living is a learning center or a hub designed to enhance learning on a specific topic. Sustainable living describes a lifestyle that attempts to reduce the use of Earth's natural resources. So in terms of what I'm providing in the center, so for the program, as I mentioned, inculcation of a sustainable lifestyle, use of local arts and crafts, and teaching of vernacular techniques. From the architecture through the building mass and form and use of local materials, the idea is to teach the inhabitants through the architecture. In terms of the design approach to the dissertation, the idea was to focus on providing 3 types of learning spaces essentially. First was the direct learning space, then the applied learning space, and finally an interpersonal learning space. The eventual goal was to provide thermal and visual comfort to these spaces, as well as thermal and visual delight. So when I say comfort, I mean being inside the comfort band for a particular comfort model. And when I speak of delight, it's focusing more on the experiential aspect of design. Through this, the comfort aspect would inculcate habituational learning by the use of adaptive opportunities to achieve this comfort, whereas in terms of the delight aspect, it will inculcate sensorial learning through the experience of the space. And all of this would eventually, idea is to inculcate the eventual theme of the project. Just to give a little bit of the context, it's located in the city of Kolkata, which is a 22.
Found the button? Below? So it should be good.
Okay, yes, okay. So just providing a little bit of the context of where the site is located. It's situated in the city of Kolkata, which is 22.655 degrees north, very close to the Tropic of Cancer. And zooming in a little bit, the site is further located in a park called the Eco Park in the city. Moving on to the climate analysis of the place. Broadly, the climate can be divided into 3 major seasons. First is the hot, dry period, which has moderate to very high temperatures during the day and higher swings. The second is the warm, humid period, where the temperatures are moderate all along, but the swing is really low, so giving very high relative humidity of approximately 85% on an average. And then a cool period where temperatures are moderate and the swing is a little higher. So to summarize the periods, it can be broadly divided into the hot period and the cold period. And for the hot period, it can be further broken down into 2 distinct, the hot, dry, and the warm, humid. And as we know that the strategies undertaken to achieve comfort for these 2 periods can be quite different. And therefore, it was important to kind of explore these through analytical work and what are the strategies that really work for the climate. But before that, I would just like to show some visual of what the vernacular of the place kind of had versus what the contemporary city now looks like. So to the left, you can see that aspects such as thermal mass, double roof, and elements such as the veranda and the courtyard kind of dictate the vernacular of the region, whereas in terms of the urban city, it's more of multi-storied, single aspect and smaller window-to-wall ratio situation in the city. So moving on to the analytical work, and deriving from this, so a methodology was formulated. And for the first step of the methodology was establishing a base case, which came directly from what the current contemporary standards are for building. Step 2 was design optimization, which looked at reducing solar gains through optimizing orientation, shading, and window-to-wall ratios, and providing natural ventilation. Next step was elemental optimization, which looked at the envelope as a whole and therefore studied optimizing materials of roof, floor, and wall. And the next, because I am dealing with learning spaces, density tends to become quite a huge problem at times with larger densities to smaller densities varying. Therefore, it was important to further understand iterations between how the space behaves with various densities. And moving on to analysis B, where I looked at the outdoor spaces and understood comfort for the 2 types of spaces I just spoke about, which is verandas and courtyards deriving from the vernacular. So speaking of establishing the base case, it's a 12 by 8 meter space, and like I mentioned, the construction is of the contemporary standard with an RCC floor and roof and brick walls. Next is moving on to the establishment of the various densities. So I took the 3 types of learning spaces that I spoke about initially, and they each had different varying densities and corresponding loads to them. So for the case of analytical work, I took the highest density, which is case 1 of a classroom. And it was analyzed for a base case where the orientation is east-west in the case. There's no shading at the moment provided. Ventilation there's no natural ventilation considered for now, and the window-to-wall ratio is opening facing west with a 40% opening. And it was plotted for 3 typical days, picking each from 3 periods. And it was observed that what you see in the red line is the base case scenario with temperature and humidity plotted. And it can be observed that throughout the year, we are above the outdoor temperature of approximately 6 to 7 degrees Celsius. However, with design optimization and optimizing each of these aspects that I mentioned, it was possible to reduce the delta by approximately 4 degrees from the base case, hence improving comfort. And further on, I spoke about how optimizing the envelope was necessary, and therefore the floor and walls were changed to rammed earth, taking from the aspects of mass that we just saw in the vernacular image, and roof, which is a double roof situation where I took a filler slab with an added extra double roof. And this further led to a drop of approximately minus 6 degrees Celsius across the year. And to summarize kind of these different steps, I plotted the comfort percentage across each of the steps and how they kind of impact comfort. So what you see in green is what are the comfort percentage for each of the step. And you can see from step 1 to the final step, the comfort goes up from 8% to approximately 82%. And just to focus on what are the major key driving aspects that drew this and improved the comfort was ventilation and reduced solar gains via the roof. Like I mentioned about density. So in this particular case, the varying densities, it was observed that it did not show much of an impact on the comfort itself, and this could probably be attributed to how the space is naturally ventilated and kind of neutralizing the gains. And moving on, the outdoor setup was such that it was adjacent to veranda space and then the courtyard space. So these were the two major aspects that were kind of studied. And UTCI studies were carried out for the verandas, and it was observed that with optimal shading post carrying out shading studies, it was observed that approximately 60% comfort could be achieved for east-west facing verandas as well as north-south facing verandas across the year for occupied hours. Also, the courtyards were studied for wind. As I mentioned, humidity is an issue in the area. Therefore, wind velocities and wind speeds were important to be there at pedestrian level. So therefore, an enclosed courtyard versus a single open versus a double open courtyard were tested, and the wind velocities, as expected, did seem to improve in the cases. And moving from that, taking from the analytical work, a form was developed for the project. But before I get into that, I would just like to place a little more about the context of where my site is. So it's located in a park, like I mentioned, and the park itself has a number of different activities going on around it in the form of handicrafts market, a cafe, amphitheaters, different museums, etc. And now developing on that the program of deriving for the 3 learning spaces. So the space tested of 12 by 8 meters was directly taken here and multiplied based on the requirement. And in terms of organization of each of these, for the direct learning space, it was more imagined to be a little more formal and organized, whereas for the applied learning, it was more organic, clustered with niches and breakout spaces. For interpersonal learning, it was imagined to be a mix of both with semi-formal spaces. So just an overview of the site in terms of how the sun angles are really high being in the tropics. The summer winds are from the south and the winter winds are from the north. For the zoning of the site, taking the spaces I just defined, I zoned them and left a big central green open to kind of integrate with the bigger park area. And the orientation was north-south as we derived from the analytical work, and there was south left fairly open to allow the free flow of wind in the summers. A pedestrian circulation was added to connect these blocks, and then a series of steps were taken to reduce radiation on the envelope overall. So the first step was staggering it in plan. And the next is staggering it in height to reduce it on the roof, and then further, as we had seen, adding an extra roof to further reduce the radiation on top. And this was then added on with more pedestrian links to link all of the spaces, all of them being shaded. And then further smaller courtyards were inserted between the space to act as breakout spaces for these workshops. And Wind was tested, however, it's not surprising that the wind velocities were a lot lower in these courtyard spaces, and therefore chamfers were created in the wall, which led to an improved wind speed, as you can see here. And after this, it could be derived like a hierarchy of outdoor spaces that were generated, and which is verandas and terraces, smaller courtyards, which would be more intimate courtyards for zone-specific activities, mid-sized courtyards, which would be spill-out spaces and could act as exhibit spaces as well, and large central courtyards, which was essentially a continuation to the existing eco-park. So deriving from whatever materials I've used, I arrived at after carrying out the analytical work. This is what the developed form kind of looks like. And now comfort studies were undertaken to understand where I am in terms of comfort after having gone through this design exercise. And firstly, the outdoor spaces were tested for UTCI to understand comfort, and they were plotted across the 3 typical days and for 4 different hours of the day. And it was observed that during the warm, humid period, one could expect to be comfortable most times of the day, except the very high solar hours at 12. However, in the hot and dry period, only the evenings could be fairly comfortable at around 8. Whereas the cool period, you could be outdoors almost all day. So for testing the indoor spaces, the workshop was picked as a test, and one of the workshop was chosen. On the right, you can see an exploded view of that workshop space, just to understand how the space finally was evolved to achieve the design goals. And therefore, you can see these smaller niches which would facilitate smaller group activities in a hands-on workshop space. And the idea was to provide each of these spaces with a shaded spill-out space in the form of smaller courtyards, verandas, or a terrace space. And what you see above is how the roof framework has been developed. In terms of the inputs, it were all derived from what I took the inputs, finally got the inputs from the analytical work. And this is what we see as the thermal performance of the space in a base scenario, where in the hot days, the space has been ventilated, whereas on a cold day, it's been minimized, the ventilation has been minimized. However, it was very important for me to incorporate adaptive opportunities for the occupants, and therefore, a strategy was developed which would further improve the situation. So for a hot and dry case, decoupling during the afternoon and night ventilation improved the comfort significantly. And however, in the cool, ventilation improved the comfort. And this is kind of the comparison between what an existing, whereas an adaptive scenario would improve, which is approximately 7 to 8% across the year. Another aspect that I dealt with in my dissertation was the sensorial aspect, as I had mentioned earlier. And one of the ways of achieving that was through alesthesia, which is temperature variations from outside to inside. And to just define what it is, it's a change of sensory experience that can be perceived by the internal state of an organism. So therefore, it would lead to moments of pleasure and thermal delight. That was the idea. And to understand that, I kind of cut a section through the space to understand the indoor and the outdoor comfort at different days of the year. And this was taken for 4 o'clock in the evening. And just picking one of the case for warm and humid, you can see that the comfort varies, the temperature varies from outside to inside by about 3 to 4 degrees, as 35 degrees is hot in the sunny area, 32 in the shaded, and 28 in the indoor spaces. Just to conclude, here, these are some of the visuals of how I'm envisioning the project. Finally, this is the visual of the mid-sized courtyard, the smaller courtyards, the indoor workshop spaces. This is a view of veranda breakout spaces from the classrooms. This is a view of the collaborative hub, which is the interpersonal learning spaces. And this is an interior view of the same. That's it. Thank you.
Oliver, would you like to? Can I give you?
Okay. Rammed Earth is beautiful. Amazing presentation. It was very clear to follow your train of thought. I particularly like the fact that the amount of time you spent on the design thinking, studying the vernacular, all the lessons you took from that, and you spent a lot of time just thinking with those elements and moving forward. And then you started testing things, which I think it's really pleasing to follow. So now that the Learning Center, obviously you detailed the amount of the different densities. There are some constraints about the Learning Center, and I was wondering how there are a lot of constraints that I'm sure you're aware of having this density inside those spaces in that climate. And you've chosen a certain number of solutions, such as the rammed earth, and you mentioned quickly the thermal inertia. There are a lot of considerations that you probably have in mind that you didn't necessarily point out, which I think I would have liked to know more about. That's all I'm saying. For some examples, such as securely ventilating, such as rainwater protection against exterior rammed earth.
Right.
Basically, rammed earth is a beautiful material, but it poses a certain number of constraints. First, the structural one: how high can you build with rammed earth? Can you use it for the flooring? Can you use it actually for the ceiling? It's actually good for acoustics. If it's outside, it should probably be protected, because in case humidity or rain, then maybe the rammed earth could decay over time.
Yeah.
Maybe there's abundant rammed earth and it's easy to make, so there's no problem
exactly.
to maintain the.
I did take those aspects into account. I just didn't get an opportunity to speak about them. Yes, but in fact, it's good for the humidity, because it kind of acts as an absorbing from the inside and releasing it outside, from studies that I've shown. So yeah.
No, and it's probably very affordable. It's low carbon. There's a lot of things that are perhaps obvious, but to state the obvious and summarize it is important for speaking in public about the qualities of your project and your decisions. So I think you defined the shoebox and the site, obviously the Eco Park in Calcutta. You're still in an urban environment, but you've got a park around, which is quite convenient, because then the air quality is better, it's fresher and all that. I was wondering if behind the shoebox at first, the classroom that you then declined into, that you went further into, did it come from a certain number of references or built precedents that you had in mind that are, is that a configuration that exists in Calcutta?
So not particularly in Calcutta, but for the program I did look at, say, CAT in Wales, which is the Centre for Alternative Technology, which has a sort of a similar program of providing workshop spaces, classrooms, and demonstrations. So that was kind of where I took the program from and derived.
Thank you for your presentation.
Thank you so much.
Thank you for the presentation. I think you have very, very clear, very beautiful graphics. It's very easy to follow. It's very, very compelling to the eye. I think overall you have a really good project. It shows a good performance. I join Olivier in the comment of having a park to design while you're in an urban environment that perhaps makes it a little bit easier. But even so, I think your program kind of suits your site. So I think that is believable. So within all this process that you have followed, I think from an architectural standpoint, it makes a lot of sense, and the spaces are well informed. I have one point that I think I would like to be more convinced about when you talk about your project. That is the program. So what is the need that your building is satisfying? Because we're talking about a center for sustainable living, and that can be perceived in many different ways and interpreted in many different ways. So if you were to present your project again elsewhere, I think I would put more emphasis on why a center for sustainable living is required nowadays. I think in this room we're all aware that climate change is a pressing issue, but what is your building offering? What is it doing? Is it informing the wider population? Why is that needed? Do we all need to change our behavior? Obviously, yes. How are you going to do that? I think that need for the building that you have successfully designed, it needs to be more obvious at the beginning, so the whole story kind of like builds on top of that. And then I found a bit strange, but maybe there is a reason for it, that you developed or like a part of the analytical studies on a shoebox before we got to see the site. So at the beginning we had a shoebox. I didn't have too much context, and I was wondering where we're going, whether this was a prefabricated building or not, like your colleagues, but I see there is not. So perhaps in the story it could be made more clear why we're looking at the shoebox and then the site, or introduce the site briefly at the beginning and then continue with analytical studies. It's a matter of narrative for the presentation. Yeah. And just a quick one, I joined Olivier on the comments about the round Earth. There are a lot of constraints that it implies. So just mention or describe them quickly, so to show that you're aware. Because otherwise, for someone from outside, it could be very easily disregarded as the rain is going to wash out your building. Normally you need these protections for the rain, or if you don't have such a good protection, then you will need to start adding concrete additives to your wall. If you add a lot of concrete to your wall, then it stops being a round earth wall and it becomes a concrete wall. So that negotiation, just keep it in mind for the future. Thank you.
Thank you. Maybe we can call Flo to make some comments now.
Yes, of course. Thank you. I think that overall you have a very ambitious project, which in your own terms you managed to make it very successful. You have a climate that is very hot, and to improve outdoor conditions in a classroom in such a climate is not evident. So the fact that you reached that in such an ambitious project is pretty good. I wonder how you sorted out the ventilation. I missed it, but in the end, the key problem of classrooms is ventilation, and maybe I missed it again, but I wonder how you sorted it out. And I joined Rafael's comment in the sense that I found it very difficult to relate the initial studies with the last image. You showed one image where we could see the classrooms, but I found it difficult to understand where it is in the project overall. So in a general way, I think that you managed to do something that is very successful, but I have a couple of questions of how does it anchor to reality in terms of ventilation, or as Rafael was mentioning, in terms of program. It's difficult to understand what is the type of program and how it's organized in the plan, and how does it respond to those shapes you have. Maybe you thought about it already, but it would be good to understand it, because in the end you have a project where you studied so many things and you managed to achieve such a good performance that it's a pity to lack those anchors to reality. And also, just one last comment. Was the wind scale inverted? Because you were showing the wind plans, and it seemed that.
Is this what you're talking about?
Maybe I don't manage to see from here. The dark blue says 0, right? So yes. You have the highest on the bottom and the top. Okay, no, maybe it's from here that I don't manage to see it well. No worries. Yeah, so in general, the plans are at a very large scale, and the building is sorted. I think that we're missing a scale in between the windows and these massing plans. It would have been good if you could develop more that building in general scale.
Thank you, Flo.
You have some very nice images at the end of the project, and I had seen them before, but both before and now, seeing them again, they are a surprise, because I mean they in a way they come out of the blue, which is fantastic, you know, but we also want to be able to connect things, and we have these end images, and we have a process that included analytical work, and I think it was mentioned by Flo, but when I look at the first model of the classroom, I can't connect it, I can't compare it with this stuff. Because that classroom looked like having arbitrary dimensions. It was single-sided. No reason whatsoever for it to be that, and therefore not possible inspiration for anything.
Yeah.
So then what was the inspiration? So we have a disconnection there, which you need to explain. So that's one point. Then I have a point which in fact is addressed to everybody else as well, which is about comfort hours. So in all the presentations, this percentage was given. It was a percentage that was always lower than 100. So therefore, there were hours that were not comfortable, and well, we've never discussed them. So how uncomfortable were they? How long did not comfortable last for?
Yeah.
I mean, these are the crucial questions. Not necessarily the comfort hours, but the discomfort hours. It could be that a project is stopped and not continued because it looks like the comfort hours are not that great. But it could also be at the same time when you analyze the discomfort hours that they were not so bad. Yeah, and I think at least a comment should be made, because it will help several of your projects that do not appear to have very good comfort hours. Now, you have good results at the end, something like 80%. But again, you know, what's the other 20% doing? When is it happening? For how long is it happening? Whom is it affecting? Is that a problem? Can it be improved? In order for it to be improved, we need to know more about it. So these are my comments. In fact, the comment that I made about the surprise between the outcome and the input towards it, I think does need an explanation. Maybe you can say something about this.
So I feel like the difference between so the idea was to evolve from what I established from the space that I was analyzing, which was a 12:8, and then I kind of did. So these were the initial boxes that I took, which are the same spaces that I kind of initially analyzed.
I'm asking why, because 12:8 by definition. I'm asking the question why start with this, because by definition, a space 12:8 of a certain height, well, I think we took it to be quite high for large volume, single-sided openings will have a passive zone that will not be very good.
Yeah.
You have freedom of starting point. Why on earth start with this? I mean, I can't, you know.
So for this, sorry, okay.
Thank you, Surabi. I mean, I was about to say the same comments as Simons about the comfort hours, although at the end you showed comfort hours and temperatures. At the beginning, you were only showing the comfort hours, and I agree that that's not the best way to approach, especially in this climate, with the materials you're using, which include a lot of thermal mass, because the difference of the temperature, which is outside what you defined as the upper comfort limit, may be low or may be high, and this we can't see. And maybe it was so low that just using some fans, you could just go into the comfort zone. So I think that starting from the beginning with the comfort temperatures, I think could be more helpful in you deciding exactly which strategies to improve or not. So, I mean, although it came at the end. Then the other comment I had, I mean, I don't have many things to add, was about about the wind speed on the open spaces, we saw different of colors, but you know, it shows there between 0 and 2 meters per second, and the things you managed to achieve are closer to the 0 than to the 2 meters seconds. Okay, it's an improvement, but how much does this change affect the way you feel outdoors? Maybe that could be more clearer, you know, transmitted. But otherwise, I think, yes, you've provided very, very interesting design at the end, and I also liked very much the visualizations that you were able to create, and thank you for your presentation.
Thank you.
Just wrapping up a bit quickly, sort of, in addition to what was commented, I would like to add a few things. One is about the form development. Yeah, that has to do with the discussion of the classroom as well, where you have the 3 different types of learning spaces. And it never occurred to me, just today, when you showed these different ways of starting the form development. In a way, all of them benefit from transitional spaces, balconies, courtyard. Mm-hmm. And then I was wondering why the formal organized, why the more direct learning has to be more formal organized. Maybe the best way of presenting them is establishing this relationship with the outside, the possibility of spilling out, and the relationship with the different kinds of outside spaces that you nicely created a hierarchy. Mm-hmm. So that was one point. Then right in the end, when you talk about thermal delight, you mentioned the temperatures. That was very clear, but then there's so many other variables. Not so many. There are some other variables for thermal comfort and delight. You know, the surface temperatures, the more or less wind, definitely these two, and even maybe being the shade, or being the sun, or being the partial shade. So if you could, and you have this data from your simulations, if you can add more to that, you can characterize the experience, the sensory experience better. I would encourage you to do that. Otherwise, it's just temperatures, and you have these massive walls that will have very low surface temperatures, hopefully. Yeah. And would probably be a delight to be seated on this floor or touching these walls. So explore that too as you got that far. And then my last comment is about, still applicable to this section, and this relationship between inside and outside, that it's possible for so many hours, so long in the year, that would be nice to see a day in the center, or days in the center, like we were talking to Anaga, I think was Rafael who mentioned that, different days, and show that movement, the dynamics of learning. There will be moments that will be possible to have a classroom outdoors. It's not just to sit out and chill out, but actually have a learning activity outside. So maybe days where you could show that, it would make justice to the concept that you initiated. Of course, in addition to the clarifications that Simons was asking, and other reviewers as well. Okay. So thank you very much. I think we can move to the last presenter, but thank you, Srubi.
Hello everyone. So my project is about marine havens, which is transforming the oil platforms into habitats for climate resilience in the tropical climate. So in order to address the rising sea levels and disappearing islands, which results in climate refugees, as well as the oil platforms, which are either abandoned or deployed in the deep sea. This means that the structures erected to extract oil from deep sea water have become obsolete. The structure being capable enough to sustain for over longer periods are being put down in the form of scrap materials. Hence, it is important to retrofit what is already in the seawater, such as oil platforms, fusing it with the current trends of a floating city with the adoption of new technologies. These platforms are owned by ONGC, which I am taking into consideration, and are located on the western coast of India, which is rich in marine ecosystem with stable sea and currently a tourist attraction. And on the other hand, according to the marine biologists who have been studying this zone, has remarked at this zone for the various research and studies to preserve the reef. And therefore, if you see the existing location of the platform, which is 10 kilometers away from the port, which was planned to extract oil. However, this platform, being adaptable, could be relocated up to 2 kilometers away from the port, achieving the minimum depth for the structure to be fixed. The main reason was to reduce the marine risk and have an easier commute with the existing port, which is at Porbandar, where the boats and ships have docked already. So the latitudes which I am taking in consideration are 21.32 degree north and 69.38 degree east in the tropical climate, where the average yearly temperatures are 26 degrees with diurnal swings up to 10 degrees Celsius. The temperature graph clearly shows two periods, warm and humid for the month of May to September, while other months as the hot and dry period. So here the key strategy is to have shading and natural ventilation throughout these periods. Before going ahead, the space contemplation of the sea and the natural climate was observed for whereas for the outdoor comfort, extreme heat exposure and high wind velocities are threat. And for the internal spaces, primary consideration was the connect to the sea while maintaining the adaptability and to achieve permeability as well as the privacy. So the existing ground of the platform is 100 by 35 meters, where the structural grid which is existing is 10 by 12 meters, which further, when we see the existing floor height of the platform, which is 10 meters, which was to accommodate the heavy machineries. But as for my proposal, I'll be adding floors in the existing platforms, achieving the floor height of 3.3 meters. The platform being narrow and to create a wider ground space, two platforms are connected with 10 meters apart as a unit, as one unit together. So considering the master plan of the whole cluster to see how the unit will be collaborated with the other units, the project as a cluster is manifested through a series of platforms that can accommodate the infrastructure. Hence, more units are connected together, forming a cluster for maintaining a circular economy. The units of the cluster are further attached with the bridges through water and through water transportation. The distances are concluded from balancing the connectivity, walkability, and by preventing the wind shadows on each platform. This further clusters could be expandable through attaching a dock which is called the arrival level for the cluster. And further, I simulated the cluster in two orientations, which has the potential with the connectivity to the port. The result shows that the cluster oriented true to the north received the required wind exposure, which is between 2 to 3 meters per second for the screen, which I'll be adding as a barrier to cut the high wind velocities. However, for my study further, I've taken the lodging unit and detailed it further with the research and design. The first step was to increase the distance between the platform for achieving more air movement and adding the curve on either sides, concluding from the aerodynamic studies. The major bifurcation of the program for our communal spaces, open spaces, private spaces, and the services along with it, which accommodates in a singular platform. For the base conditions, the lower platform is kept for the entrance of the guest and for the future sporting events which are related to the water. The courtyards are arranged in a form to connect the indoors and the outdoors resulting into a better quality of spaces. And the private spaces, which are mainly the guest bedrooms, are oriented east and west to maintain the privacy and the view to the water. whereas the communal spaces are oriented inwards to get the more unified and open envelope. So the built form is derived to achieve a lot of air movement by cross ventilation using wind driven and stack effects. The depth of the floor is not more than 10 meters, which is the existing structural grid which I have in the platform. As facade receives the uncomfortable winds and lots of radiation, it was essential to design a skin. Here the precedent studies have shown designing an aerodynamic shape which creates less wind forces on the facade. So therefore, the three screens with different perforations were tested in relation to the interior spaces and the courtyards, which has the same principle as the precedents, where the screen shades and controls the wind forces. These tests were for two major spaces, which is a room and a courtyard, where the result shows that the screen 1 blocks a lot of radiation and also reduces the wind on a greater amount, cutting the visual connection, while the screen 2 with perforation ratio 60% performs well with the courtyard, maintaining the wind speed, and screen 3 for the rooms. However, for the rooms, the captured wind is further controlled through the design envelopes for the individual units. Taking it further, screen 2 and with perforation ratio 60 and 80 is to be distributed on the overall skin of the built form. So according to the aerodynamics of a ship, the built form is achieved with the north and south of the platform having the buffers which accommodate the public activities and the open terraces, and the tilt helps in shading and in addition to the screen which controls the wind movement. The overall distribution of the screen as per the space is where screen 2 in front, which has a perforation ratio of 60%, is in front of the central courtyard, and the communal spaces between the platforms to not have a secondary skin for the communal spaces. And to balance the form, the functions are mirrored to the adjacent platform to have a view of both land and ocean on two adjacent platforms. So the solar analysis shows the cumulative results of incident and as well as the reflective radiation from the sea with and without the screen, which shows that the reduction of 20% of radiation for the southwest facade and 30% for the northeast facades. In addition to the vertical surfaces, as the roof receives the maximum incident radiation, designing a canopy to allow use of terraces for the communal activities with a ventilated roof strategy. So here I have considered two permeability of the roof, which is 40 and 60%, whereas the thickness diffuses roughly about 20% of the direct radiation on the roof. So in taking the roof in terms of wind, the roof is designed curved while keeping the screen high, diverting the strong winds from the north when it's facing the north, whereas when the lower angle of the adjacent platform is facing the north, the wind lets the flow through the slope of the roof which is designed. The unit's roof were simulated, one with the roof and other without the roof, as a result of which the grid roof offsets from about 640 to 480 kilowatt hour per meter square in the period of high solar radiation, which is from February to May. So further going into the built envelope of a unit, the idea of building envelope is to keep adaptable and connected to the context of water while allowing good air movement and adaptable through the unit. The screen, which is in front of the units with 60% of the shade, with 60% of perforation, controls the wind and provides shade where the guest rooms open up into the balcony space. Further, the envelope lets occupants control the light as per the comfort and privacy levels. The average wind falling on the screen is 3 meters per second, decaying to 1 meter per second between the buffer space, and while through the envelope it decays up to 0.3 meter per second at the end of 6 meters. So the envelope allows to let the afternoon sun envelope allows to cut the afternoon sun into the balcony space, and for the month of December, whereas admitting the evening sun for the 3 solstice periods entering through the skin. So the flow of air is regulated by the adjustable louvers, which open when the wind is light to allow fresh air, but close when the wind speed picks up, and which allows more adaptable and adjustable comfort levels according to the occupants. For the visual comfort, the envelope with only the use of screen received more glare, which is the first simulation shown in the picture in front of the part of the unit, whereas adding the adaptable louvers, which lowered doors, increases the useful daylight limits between the given limits, whereas the units facing inwards resulted in low percentage of useful daylight. However, for the units facing inwards, the glass louvers showed an increase in the use of space. So here I've limited the use of glass, but also achieved the required visual comfort for the units facing inwards. So the building having a highly efficient passive ventilation system, which eliminated the need for the mechanical air conditioning. The operative temperatures were examined for a day of 15th of March, when the radiation is on peak. The result shows that the 40% increase from the base case of typical construction to the final case of adjustable louvers and more air movement. So the base floor of the platform has communal spaces promoting more outdoors in regards for the water activities and on the decks and for the retail purposes. And this is a typical floor on the 4th floor, accommodating the guest rooms on the east and west of the orientation to maintain the privacy and connection to the water views as mentioned earlier, whereas the communal spaces which are oriented inwards being adaptable in terms of envelope, having open spaces with the only screen in front as an envelope. So the top floor accommodates the restaurants, cafe, and taking the advantage of height, the connection is maintained to have an aerial view of land as well as the ocean. For the outdoor spaces, which I mentioned, UTCI results, results show that the roof allows the usage of terraces in the evenings, that is after 5 p.m. However, during these times, shaded spaces can be in use. In addition, an installation by Coolant Design Studio from India, where the conical terracotta pots cools the dry bulb temperature, resulting in a temperature reduction of 2 to 5 degrees depending on the wind speeds in hot dry periods. During the period of high humidity, the pots will absorb the moisture that is in the air. So this is a view of the terrace at 5 o'clock in the evening, which achieves a temperature of 29 degrees with the wind velocity of 1.8 meter per second. With the day passing by through the evening, the usage of the space changes to having the night views and more inward and connection to the water, which was mentioned earlier. So, however, for the courtyards, it was observed that the courtyards were acceptable in the month of March at 12 p.m. in comparison to the terraces, whereas on the same time, June, it could only be used as an outdoor transition spaces. For the March, even though it traps heat, wind velocity of 1.5 meter per second adds the required movement of air for comfort. So, this is a view of the courtyard at the evening, later evening, yeah. And this is also the view of courtyard showing the connection to the outdoors. So this is a section cutting through the central courtyard, including the terraces and the outdoor spaces, where it shows that the built mass have a very clear air stratification through the courtyards and the voids. So combining all the information explored in the project, so the screen which controls the prevailing winds, the rooftop terrace acting as a major communal space, the canopy of roof as shading, the outdoor shaded spaces, the natural ventilation, the use of solar panel which could be promoted on the roof, on the canopy which is provided, and the communal gardens which are facing north could be used for as it's shaded for the high radiation periods. So this is the north side view of the deck, which is the front of the built mass, showing it in the evening period, which promotes the outdoor use. This is the same as we see panned to the front of the built mass, and the north shaded viewing decks. These all are the north view on different levels. And this is the south-facing communal gardens, which I talked about, which has adaptable envelope for the indoor spaces, whereas the outdoor spaces are used as more of a communal gathering spaces. So to complement both the purpose of usage and aesthetic on personal level of architecture forms, this is how a complete research and design outcome is for my dissertation, and these are some more views. Yeah.
Maybe Flo, can we invite you to make some comments there on the other side of the Atlantic?
Thank you, Joanna, and thank you, Zil. I want to first congratulate you on the topic. I think it's very, very interesting, and it is needed, and it's so important that we as designers also try to address these kind of topics that are needed, and not only something that we would just like to do. I think I had never thought of these kind of structures. I think that what you brought to the table is extremely interesting and complex, because your site is very difficult. It's difficult to relate to be in the middle of the ocean. So I think for that is great, and I think that in general terms, the solution that you found of putting a screen that would be the same one in all of them is the best thing of your project. It's as if a plugin would come to any of these platforms to make it livable, and it doesn't matter what the inside hosts. Actually, I find a lot more interesting the big action of saying, to make this space livable, we need this screen that will be in this way, and then everything becomes livable. I find that super interesting and a really good project. I have some reserves on the durability of the bamboo in the middle of the ocean, but I will leave Olivier to that, who is an expert in that. And I wonder also why did you rotate it? Because you usually showed two of the platforms together, and why did you rotate it the round part of the screen? Because in the example you showed, actually the round is precisely to divert the winds, as you just said. So why would you put it in a different orientations in two of them? It's an open question. I'm not sure it has an answer or not, but I think overall the big approach of your project is great. I find maybe the smaller scale is not as developed, but I think it's good. I think it's less interesting to go into the smaller scale, because in the way you sorted out the big scale is great.
So for the like mirroring the functions, the major aspect when like I wanted to show that the screen of holding the curvature in both the orientation could work, because as a cluster, if we see these smaller strategies will be applied for the whole cluster as a whole, those smaller perforation ratios and could be changed, but the overall aspect of dividing and distributing the screen on the different clusters with different typologies, such as with what I am considering here is the lodging platform. But when I talk about a cluster, I have a living platform, I have a platform just for the Marine Institute. So to see both the aspects and also to have a view of land and sea together, which I thought would have made sense to orient it in a different way.
Okay, thank you.
Thanks for the presentation. I was thinking, because I thought the topic was very original, and I was thinking why, and in the end, it's an oil and gas process equipment that is left there. And, with the times changing, obviously, the scarcity of resources, the contraction of all resources and all that, we could expect that in the future, many of these installations would remain there, be left or abandoned and disaffected, right? Mm-hmm. So in the end, it's an available structure, steel structure, that is up for grabs, basically, either for destruction, either to rot in nature, and you use it into a contemporary use. You reuse it, basically. So in the end, the advantage of this project is that you're not consuming carbon for the structural element of a new contemporary building, right? Which is a major carbon argument,
yes.
Right? And then all these questions rush to my head. It's like, how much does it cost an oil rig? Can we buy one? Is it cheap? Is it just a rotten if it's left there? And then you're moving the oil rig from its original place to other places. Then I started thinking, okay, well, what's the impact? What happens underwater? What's the impact on biodiversity? What do you do on the seabed exactly? Meaning then, if it's something, then I started asking, okay, what can happen in that environment? I wasn't sure of I didn't fully understand the program that you proposed in that environment. I was thinking, is that only rich people that go with their yacht and get to this place or not? Okay, is it the whole community that is autonomous, that is living? How far from you showed the distance to the coast, but then it means that in the end, if these are transportable, if these can be placed somewhere, then there's probably a wide range or area where you could actually install it for various considerations or constraints or what. And then, it could be a PhD topic. I don't know, it could be a huge topic, but very interesting. That's why there are all these questions, and I'm aware you can't answer all of them. The last thing that what Florencia was saying is that it's very difficult to understand the conditions at sea, right? How I saw that climate graph, I had never seen a climate graph like that, with this constant range of diurnal temperature in the middle of the year, really high humidity constant, the wind, you probably have reverberation, the amount of glare inside those spaces, yes. You calculate UDI, all these constraints. It's kind of an alien, it's a different planet, right? And I think having that extremely clear of how different you're importing vernacular strategies from inland and you're using them offshore in the sea. How are you transforming that? And great presentation.
Thank you so much. Just to answer that, when we talk about underwater, so when the existing platform is located 10 kilometers away, when they are extracting the oil, the marine life is not on the skin of the platform, it remains barren. But when we relocate it to 2 kilometers away from the port, where marine biologists have told that is called an interdial zone where it is rich in coral reefs, where the coral reefs which will get a surface to attach and to grow further, and that's how it could be more adaptive underwater as well. Yeah, so just to answer.
Thank you, Sid, for the presentation. Yeah, I'm going to join my colleagues in congratulating you for the topic. It's a very interesting topic. I had never thought about it, and now you're bringing it to the table, so that's commendable. I have one question before I move on. That is, are you refurbishing an existing platform that is on site, or are you moving one that was elsewhere? Are they movable? What is there one over there?
Yeah. So there are.
Or there are two. Sorry.
So in existing condition, there are 300 platforms on the western coast, which are on different kilometers. Just 10 kilometers when we talk about is the average range, but in that 10 kilometers, there are 300 of oil platforms, which are in next 10 years will be abandoned or being obsolete. So what they do is, as an environmental strategy, they just deploy the structure in the deep sea, because the material taking out from the sea to the edge of the onshore and to converting into a scrap material costs them more than what it was built for, for the cost which involved in the building the infrastructure. So, and they also have the platform which I took into consideration was the fixed platform, which can be relocated. And there are different types of platforms, but I chose this because it could be more relocated and more converted into a livable format, and that's how. And they have pile foundation that could be relocated. Right? That is the technical.
No, okay, thank you. Yeah, because I saw at the beginning that you were pointing one, and then I saw a cluster, so yes. I got a little bit confused whether you were building one that I thought that you were not, and whether they were movable or not. So just for someone new to the topic, probably it's helpful to clarify that. But I think other than that, it's a fascinating topic. I'm going to build on a little bit on what has been said before, the big screen that you have studied, obviously to shelter from those alien conditions that we are not familiar with in the middle of the sea. Obviously the wind, it's a major issue over there. And I think it's a very interesting exercise what you've done working on the outer skin, the major gesture of your project that kind of unifies what happens inside, and then a more almost domestic scale on the inner screen that can be adjusted, that can be adapted by the occupants. So that duality between the big gesture and what people can control, I think it's very interesting, and it's very commendable that you put it forward. I would like to know a little bit more about the program that you have in mind. Obviously, these are abandoned structures, so whatever we can do with it is already positive. No, but I think what Oliver was mentioning is it's a tourist place. I think you had a very interesting topic at the beginning, mentioning climate refugees. Can this be used for that? If so, is it self-sufficient or not? Obviously, you've opened a door now, and we're all throwing at you a lot of interesting questions. But yeah. I think it's just the topic that is really, really well chosen.
Yeah. So, sorry. Yeah.
Maybe if you want to answer super brief, because we also want to
hear
things that follow. You can give a brief answer.
Yeah. Just to mention that I have mentioned these typology which are mentioned below, which is the living platform for the communities, for the Marine Research Institute to have a research underwater, and the lodging platform which I have studied and researched further to derive a strategy which could be taken further for the clusters which are mentioned here.
Okay, thank you.
Thank you, Zil. Good development and very nice presentation. Congratulations. I have basically one question and one comment. So I like this master plan that you've proposed, and I also fully support that you decided to focus in one, otherwise it would be a too large project. So you decided to focus on the lodging platform. But all your analytic work was considering those two platforms isolated. And I'm just wondering, because although you did studies from the air movement from the courtyard, but you relied a lot from the air movement coming from the seaside. And I just wanted to know if you considered if blocking, like this image shows so well, would still provide the same amount of airspeed that you are imagining. Then the other comment was, well, I had actually two. Yeah, well, in regards to the occupant, which I knew before, but it's true that here probably you didn't develop it a lot because of time constraints. I forgot what I had. One of the questions is, I agree with Olivier that retaining those structures is quite a good way of making use of them. But have you done any search on how much it would cost to move all the platforms into these? Because, you know, the weight, I don't know. Maybe it's outside of the remit of your dissertation. And my last comment is, it's a small comment, but I think it's important. You have very nice visualizations, especially at the end, but I never saw any of them showing the access. How can you access from the boat to the platform? Yeah. There is no stairs, no lift, nothing. No, you have to put something.
Yeah, I've not mentioned in my speech, but I've considered that.
Pardon?
I've considered that transition.
All right. Yeah. So, all right. Thank you. Thank you very much.
Thank you.
Well done, Jill. Great development since a few days ago. I noted here the following, you can quote if you wish. These are floating structures that are made to look like a building that looks like a boat. And perhaps it is because of that there is a bit of confusion in our minds about how to treat them as a boat, as a building, as some hybrid, some new hybrid. So it's very interesting and a very imaginative scheme. And you've done a great job. The only problem that I had with some of these spaces, which I think you have explored quite well, is that they are huge, yet they feel a bit claustrophobic. I think it's the screen has taken over and covered everything very conveniently. Well, now you need to, see how can one escape. Because you see these people there, they turn round and round. Then when we go to the edges, let's see. Okay, I mean, this is an amazing image, which I think becomes quite evocative and iconic, and you can sell this. But when we enter the major spaces, it appears like there is a lot of wasted space, and I think that may need some further reflection. But anyhow, that does not detract from the fact that you have created a very interesting scheme. Well done.
Thank you.
Super fast, Zio, to conclude this set of comments. Thank you for this beautiful project. One request maybe, and I'm not saying that you didn't do, but I think you have it, but if you can be clear when you present your project in your book, the design process of the roof, that it wasn't clear, you just show us the roof with a certain grid, with a certain dimension, whereas everything else has been scenarios, alternatives, tests for different situations. So I would like to see a bit of the research process and the design thinking for the roof. I know you have it, but just make it more clear. There are other aspects of the scheme that, the plan depth, the floor to ceiling height of the bedrooms, aspects that you thought more when you come to the building side of the project rather than the boat side. That works well for ventilation, for stratification. Make sure that this is clear as well. And I have a request. I completely agree with Simons. The spaces seems too big, but maybe that's what they are. You can explore activities, use different uses, but can we have a wooden deck instead of a plain white floor?
Yeah.
It's a silly comment, but
yeah.
Now looking from the boat side, one of the images, maybe because of the sky and the whole thing is very attractive, but then there is a small level of quality that you can improve and make it more attractive. Yeah, no more words. Thank you very much.
Thank you so
Great.
much.
Thank you, everyone, the presenters and the reviewers. We will now make a half an hour break, just on time, a little bit more, and then you're welcome for the keynote speaker. Okay? Thank you.
We just mention that we have a number of other MARC students that could not present here today for different reasons, mainly time, because we had a restricted time. Their topics and locations have been constantly announced here between the dissertations. And to thank all the MARCs that were here today for putting so much effort, so much sleeping hours into the show they gave us this afternoon. So thank you, all of you. Now we go for a break.